All right, let me set the context for the video. This video, we're building OpenRouter end to end in around 4 hours. We'll start by building 2 backends and 1 frontend. The final application will be a full stack application where you can come, sign up, create API keys for a central LLM layer, just like OpenRouter does. And then you can hit our APIs to talk to one of many models. You can talk to Anthropic models, GPT, OpenAI models, Gemini models, and maybe other providers in the future by just going through a single API layer that we have. Things to learn in this video are probably going to be the tech stack that we're using. We're using ElysiaJS as our HTTP framework this time. It's an end-to-end type-safe HTTP framework that I just wanted to try over Express. We learn how to talk to LLM APIs. We'll also do some level of credit management. How do you let end users on-ramp credits on your platform, and how do you decrease their credits as they start to hit your APIs? Mostly, it's a fairly simple CRUD application, but you can probably learn a thing or two about AI, or how do you talk to LLM APIs through the video. OpenRouter in itself is a fairly hard product to build. We've built the first layer of it, which is usable, but there are a bunch of features I've left at the end in case you would like to build on top of this and contribute to the project. In this video, we'll also be using Requestly as our API client. This is a fairly API heavy sort of an application to test all the endpoints that we're hitting and making sure they're working as expected. They're also sponsors of the video. I would urge you to check them out from the link in the description. With that, let's get into the video. Hi everyone and welcome to a new video. Today we're building OpenRouter from scratch. I hope some of you already know what OpenRouter is. OpenRouter is a sort of a new product, a central API layer that lets you connect to many individual LLMs. For example, if you have an AI application today, let's say something like a slides GPT, you might want to switch from Claude to OpenAI to DeepSeek. And a lot of times this code gets very messy. Integrating with multiple providers. OpenRouter acts as a central layer in which you only send your GPT calls or your AI calls or your LLM calls to OpenRouter. And as the name suggests, it routes your requests to one of many providers. You pay OpenRouter directly. It gives you a central billing layer, and they just take care of the underlying expenses on OpenAI, on Claude, so on and so forth. They charge a 5% kicker on top of all of your LLM calls. So if you would just use Claude or just use GPT, if you pay them $100 a month, you will pay OpenRouter $105 a month. But still, a lot of companies are using it for the convenience it provides. There is no open source version of it, even though it's called OpenRouter, it's not open source. So the goal today is to build as feature compatible of a product as we can compared to OpenRouter, open source it, and open it for the world. There are a lot of challenges in building something like this. Specifically the documentation that they have and the SDKs that we support in various languages, which will be a little hard for us to replicate. Other than that, feature-wise, we'll try to complete everything end-to-end. I've tried to go through their website and I've also used it in a bunch of products. If you really look at it, the product looks as follows. OpenRouter specifically exposes one endpoint, which is a completions endpoint. This gets a little more nuanced if you add images, videos, so on and so forth. But just for text, there's a single endpoint called completions. That's openrouter.com or api.openrouter.com/completions that your application. So let's say if I'm building an app today, my application can hit and my application can specify what model I want to use. Let's say I want to use GPT-3. Then it's the job of OpenRouter to route this request to GPT-3. And under the hood, OpenRouter also uses multiple providers. It might use OpenAI or it might use a hosted version of OpenAI on Azure, whichever it thinks provides the maximum output right now, maximum throughput right now, whichever might be cost optimized, whichever might be more available, is where it will route your request. So under the hood, OpenRouter has multiple providers for every model that they're trying to hit. And based on some data over the last 30 minutes, last hour, it'll route your request to the respective provider, and that's where the actual LLM response will be routed back to you from on the front end. That's a high level of what the product looks like. Not very difficult to build. I think the only difficult part here is going to the individual dashboards of an Anthropic, Google Vertex, Deep Infra, putting money in all of these providers and making them available for our users. Generally, most of these expose APIs or the SDK via the OpenRouter compatible API, and hence I think under the hood these requests should be very simple. In the end, there are like 10 providers that we need to integrate with. So I think the general product that you're supposed to build without any UIs, without any dashboards, without any credit system, without any API keys is fairly simple. The difficult part comes when we build, basically a B2B layer on top of this. When people can come sign up on our platform, create API keys, give us money on our platform, and then we can, route their requests to the respective provider, start to debit their accounts whenever we feel like they're hitting limits, so on and so forth. That's one specific B2B layer to build on top of this original architecture or simpler architecture of OpenRouter. The other cool thing that they have that I'd like to create today is that they rank models in terms of their usage specifically on OpenRouter. So if you go over here, you can see around 50% of the usage is from some random, other models. But Kimi 2.5 is the one that's, leading the charts right now, followed by Gemini, followed by Claude Sonnet 4.5, so on and so forth. So basically a very metrics heavy application. If we want to expose this functionality, which I would, these are one set of, analytics, but you can also expose things like which model is providing the best throughput, which model has the slowest response time when it comes to the first token response from the LLM, so on and so forth. So one, ranking models on a bunch of these metrics and showing them to our users. Feature number 3 is model performance. This is individual model performance, specifically graphs like these. What's the throughput of a specific model, for example, 4.6, the latency, the end-to-end latency. This represents the first token response time. This represents the last token response time. And then lastly, writing docs. It is a B2B product. Honestly, these are fairly useless features. I don't think anyone is spending their time on this. Just a cool thing to build if you want to understand time series databases. The docs and the B2B layer are the main primary thing to build. That's where we'll spend most of our time. And then if we get time, we'll try to build the metrics pages and try to track as many metrics as possible. With that, let's kick things off. Let's try to understand the architecture, maybe everything minus the metrics. Hence, how would you build something like this and create a B2B layer on top of that? Once we understand that, then we'll get into how would we write docs for the same. Right, the architecture looks fairly straightforward. We'll have a front end where users can come sign up, on ramp, create API keys, which would talk to a primary backend. We'll probably be writing this in Node.js. The primary backend's job is to support simple CRUD endpoints, things like sign up, sign in, let the user create an API key, let the Razor Pay backend talk to our backend if the user ever pays us or tops up their credits. Let the user see their current credits, see their usage, see the existing conversations that they've had, so on and so forth. I'm sure I'm missing a bunch of simple CRUD endpoints, but all dashboard admin related functionality will be exposed by the primary backend. And then we'll have a separate API backend, that's api.openrouter.com, where we'll support a single endpoint right now, which is the completions endpoint. The user will send a request over here whenever they want to do an LLM call, and this will, stream them back the response. Both the API layer and the primary backend would talk to the same, primary database. Let's, stick to something like Postgres or MongoDB. But other than this primary database, we can have another time series database for all the metrics that we want to gather for all the LLM calls that have happened. So the API layer will not just talk to the primary backend, but also a time series database, and also to an LLM provider. Ideally, the metrics will be exposed via the primary backend. So the primary backend would also be talking to the time series database to do a bunch of GET requests, and when I say GET requests, I mean just, the R in the CRUD, that means reading data from the time series database. And the API backend will actually be putting data in the time series database as well. I don't think we'll need any other services. We can add caching from time to time, but nothing too complicated in terms of, the backend layer or the front end layer. So I'm assuming this is going to be a fairly simple project. With that, let's get into coding the primary backend first. So we'll kick things off with coding the database. And when I say the database, I just mean writing the schema. Once we're done writing the schema, let's start and finish the primary backend as quickly as possible. Let's focus on that next, building the primary backend. All right, let's kick things off by initializing a turbo repo. That's the monorepo/build system that we're using today. Most of our code is going to be in TypeScript, so it makes sense to have a monorepo framework. Let me create a new folder called OpenRouter, inside which I'm going to run bunx create turbo at the rate of latest. I use bun as my runtime, but you can pick and choose if you want to use, pnpm, npm, yarn. I would generally urge you to move to bun though. While this is happening, let me quickly go to cursor, which is where I'm going to write my code. Let me open the specific folder, that's projects/OpenRouter. Now we have a turbo repo initialized. Let's look at the folder structure once. We have apps/docs, that's probably a Next.js frontend, I think. Apps/web, the same thing. Both of these are frontends in Next.js, which is something we don't want. Packages, we want one frontend, but not two of them. So I'll just get rid of the docs frontend for now. And honestly, the other frontend can also just be, a React project and not a Next.js project. So I'm just going to get rid of both of them. Packages have UI, which is probably going to be our, UI framework. All of our components are going to reside over here, the TypeScript config and the ESLint config. Let me initialize the set of apps that we'll need. We need a primary backend, if you remember. So bun or mkdir primary backend, and then bun init. It's going to be a blank project, which we're eventually going to convert into a backend. Then we're going to create an API backend, bun init. And then we're going to create a front end, which is, or the dashboard, I guess, or dashboard front end is probably the best name for it. This is going to be a React project. I have started to use bun to initialize my React projects. I don't know if that's a good thing or bad. I've generally used Vite before this, but for now I'm just going to use bun with shadcn and tailwind CSS. Again, it's the first time I'm doing it. Hopefully it just works as it is supposed to. That seems good. The other thing we might need is a package that contains all of our ORM code. We're going to use Prisma. So I'm going to create a new package called db, inside which I'm going to do a bun init, followed by well, there are a few steps to initialize Prisma in bun. Let's go through these steps. Before we write any of the backend or the front end code, the first thing I want to do is write, design the schema and write it. So let's go to Prisma with bun. This one right here. These are the dependencies we need to add. Prisma at type/pg, pg, Prisma pg adapter, and Prisma client. This is again all happening in the db package that will probably be reused by both the API backend and the dashboard, the primary backend. This seems done. The next step is probably bun init. Okay, the command sort of makes you log into Prisma whatever cloud offering, which I don't want to, and hence the command that I'm going to run is simply bunx Prisma init. That should initialize a new db/prisma/schema.prisma file where you write all of your database schema. Again, this depends on you if you want to use an ORM or not, and what ORM do you want to use. In our case, I want to use Prisma, and hence this is what I'm doing. There is a helpful comment here, so I'm just going to leave it like this. I think, oh no, it's in a different file, but either way, this is our schema.prisma file where we'll be writing all of our schema for the application, the user table, the API keys table, the usage table, the models table, so on and so forth. We'll incrementally make it. I'm sure I'll miss a bunch of things the first time, and then eventually we'll arrive at a schema that probably might be right. So let's do that next. Let's design the schema of our application before we write any other code. All right, I've designed a few things. To recap, this is just the primary database schema. This is not the time series database, which will store all the metrics. Just the database that's going to store, all the CRUD information. Looks something like this, I think. I've color coded them. The things that are red are of one category, green are of other categories, so on and so forth. The simpler set of things are going to be a users table where we're going to store every sign up that happens. Let's say we only support email and password for now. Every user can create multiple API keys. That's what OpenRouter lets you do as well. If you've ever logged into OpenRouter, that's the first thing you do. You put in some credits, you create an API key, and you start to hit their completions endpoint. The credits and the on-ramp transactions table, this will basically store every time you've on-ramped via Razorpay, via Stripe. Every transaction that happened over here, successful or failure, will reach over here. For all successful transactions that happen over here, the credits over here are going to increase by a bit. That's all that covers, the basic auxiliary CRUD sort of functionality that we need. Then there's the model side. There are a few tables. Let me try to explain them one by one. The models represent individual models. So GPT-3, GPT-3.5, GPT-5 are all going to be individual rows over here. These are individual models with their own set of input token cost and output token cost. So every company could have multiple models that will be present as separate rows over here. Every model will belong to a company. I don't know if there's a need for this, but I'm assuming in the UI somewhere we might want to show that this first model belongs to Google, the second model belongs to OpenAI, so on and so forth. And hence I've created a companies table where we'll store all the company information, which basically right now is the name of the company and the website. Providers, every model over here will or can be run on multiple providers. For example, you can run let's say Gemini 3 on AI Studio and on Google Vertex. You can run GPT-3 either directly using OpenAI or using Azure, so on and so forth. Then there are a bunch of other auxiliary providers like Deep Infra that OpenRouter uses. So if you open any model on OpenRouter, you will see that specific model can route your request to one of many providers. And that is exactly what this table is going to store. I'll show that very soon whenever OpenRouter loads. And lastly, a model provider mapping. Actually, I'm wrong. The providers table will simply store the various providers we support. So it might be Google Vertex, it might be Azure, it might be ChatGPT or OpenAI, it might be Anthropic, it might be Deep Infra. And then this model provider mapping is a many-to-many relationship between both of these tables. So every model can be run by many providers. Every provider might run many models. If you open a model over here, let's say Qwen3 Max Thinking, the providers over here include just one, that's Alibaba Cloud. Let's look at a different one, Cloud Opus 4.6. If you look at the providers here, there is Anthropic, there is Google Vertex, there's also Amazon Bedrock. So there are three providers that your request can get routed to if you're sending a request to Cloud Opus 4.6. So each of these providers is one row over here, and this model provider mapping is the table that stores what model is or can be routed to what provider. So in this case, for Cloud Opus 4.6, there'll be three rows in our model provider mapping. One row for the first model provider, as in the model is 4.6, the first provider, one row, second provider, one row, third provider, one row. Now that I look at this, there probably also needs to be a bunch of other things. The input price and output price are well, they're all the same here, but it seems like they could be different. So maybe input price, input token cost and output token cost shouldn't be stored at the model level, but be stored at the model provider mapping level. So the model stable will only contain the name of the model and the company it belongs to. The final provider mapping will store which provider is charging how much for a specific model. So it might happen input token cost and then output token cost. It might happen that the same model, Gemini 3, let's say there are two rows here for Gemini 3, one on Vertex, one on Azure, let's say. Then it might happen that the input token cost on Google might be lesser because Google owns the model 0.01, but it might be more on Azure 0.02, so on and so forth. So the one thing that I have changed right now, that the models table only contains what is the model, maybe some other auxiliary metadata around the model, performance, throughput, things like these. But the model provider mapping actually stores the input and the output cost, because the input output cost might be different, even though it wasn't in most cases, but it might be different for every provider. The different providers can charge different things for the same model, and hence we probably need to store it over here. Last thing is the conversations table, which is going to store every conversation that the user is going to do. So when our end users are going to hit our API backend, this one right here, there is a CRUD entry that would go to this database whenever that request succeeds or finishes. That will be in this specific conversations table where the user can come and track all the existing conversations that they've done, how much input tokens did they spend, how much output tokens did they get, so on and so forth. So every user, for one of many API keys, can send an input, can receive an output from the LLM, probably need to have model ID here as well, or probably not model ID, but model provide. It's actually a little tricky. It actually might be model provider mapping ID. Something like this. Let me just move this below somewhere. That specific request might get routed to, the provider number 1 or provider number 2. Gemini 3 has 2 providers. The specific request for this one might get routed to this guy or this guy. So we should also store, which specific provider was this request routed to. And hence the other thing I will add over here is going to be model provider mapping ID, which let's say is 1. That basically means this was the provider. That means Vertex was the provider that actually this request got routed to. If you store model provider mapping ID, it will store the model ID and the provider ID. So we don't have to separately store कि ये request कौन से model के लिए थी. We don't have to separately store what request was this model for, even though we can store it if we want. But that information is already present in model provider mapping ID, and hence we probably don't need to restore it. There's no good reason to restore the specific ID over here. It's just redundant data. All right, a few things have changed since I wrote this 5 minutes ago. It might change more. I'm pretty sure I'm missing a few things, but let's code up at least this much of the schema, and then let's spend some time writing the backend. We can write this one by one from scratch. So if I go to the schema.prisma file, I can actually start with the user's model, give it an ID, which will be a string, which will be the primary key, and which will default to a UUID, a username or an email, which will be a string, which will be unique, and then a password, which will be a string, and that's it. That's the first one. So the users table, I've translated to the schema.prisma file, and I can keep doing it. Or if I've already drawn it once, if not written it, we can also give it to some LLM to be able to based on this diagram, write the schema for us. I think either is fine. There is no downside of doing either, because I know how to write these by hand very well. So pick and choose what you would do. I would probably just take a screenshot here and hope Claude Code is smart enough to convert this schema diagram. Put this schema in my schema.prisma file, and let's see. I mean, I might totally be wrong. I think it should get us there, if not completely, at least halfway there. So let's see if it's able to parse the schema that I have and convert it into Prisma schema and add all the foreign key relationships that might exist amongst all of these tables. For example, a user and API key will have a one-to-many relationship. Every user can have many API keys, and every API key will belong to one user. Models to company ID will have a one-to-many relationship. Every model will belong to many. Every model will belong to one company. One company can have many models, so it will be an inverse one-to-many or a many-to-one relationship. Every company can have multiple models. Every model would belong to one company. Same with model providers. Maybe not model providers. Yeah, nothing here. But models and providers are actually connected through this many-to-many relationship that we're storing in the model provider mapping. Are there any other relationships? I'm sure there are many. Conversation will have a one-to-many relationship to the users table. Every user can have multiple conversations, and every conversation will belong to one user. API key and conversations would have the same thing. Here is a small interview question for you. We're creating a one-to-many relationship between API keys and conversations, and it might happen that the user deletes one of their API keys. If they delete it, this foreign key relationship sort of breaks, because if they delete an API key, they don't want an existing conversation to be deleted, and hence, along with disabled, I would probably add another field here called deleted, which will be true or false if the user actually deletes it from the UI. Even if they delete it from the UI, we should probably not get rid of the API key from the API keys table. A bunch of more nuances around, how we can design the DB. Let's see what Claude Code did for us. It did write a bunch of code. I did accept it blindly, and now we'll try to go through what exactly it wrote for us. If you look at schema.prisma now, a user table that has an ID, email, password, and also has all the relationships that I wrote. In fact, I missed some. The user table will also have a it's actually a one-to-one relationship here. So it's a little tricky. As in one-to-one relationships are not hard to design, but they're just very vacuous in the way they're designed. We'll see what I mean by that very soon. And then a one-to-many relationship here. So there are actually three one-to-many relationships: one to API keys, one to conversations, one to on-ramp transactions. That's what this guy has done. And the one bad thing that this guy has done is created a one-to-many relationship to credits. That is incorrect. A user will only have one, current balance or their current credits that they have. A user will not have multiple credits unless we support sub accounts, which is a whole different discussion that we don't want to support. So ideally, I'd probably just get rid of the credits table. So get rid of this thing right here and just store the user's current credits over here. We can also give the user some default 5 credits or something like that. But what I'm going to do is, for now, this is going to be an integer and it will default to 0. As soon as you sign up, you will get 0 credits. Whenever you on ramp, we will increase this number. Whenever you do a conversation, we will decrease this number. All right, that's the users table. There are 3 relationships that I drew here: one-to-many relationship here, one-to-many relationship here, one-to-many relationship here. And all 3 of these relationships have been incorporated by Claude Code fairly well, which is exactly what we needed. Users table is done. The second one is the API key table. Again, ID, user ID, name of the API key, that makes sense. API, the actual API key. We should add some level of encryption here. I haven't yet, but API key should probably not be stored in plain text in the database. Disabled is fine. One more thing I would like to add here is deleted. If the user does delete an API key, it should not be removed from the database. We should just set deleted to be true, so that no other foreign key relationships break. Every API key will belong to a user. Every API key will have many conversations. Company seems simple enough: ID, name, website, and then has a one-to-many relationship to models, exactly what I wrote over here. Model, ID, name, company ID, foreign key relationship, and every model will have multiple entries in the model provider mappings. The same is true for providers. Every provider will have multiple entries in model provider mappings. That is basically a many-to-many relationship right here. Models exist independently, providers exist independently, and model provider mapping is a many-to-many relationship table between models and providers. Every model can have many providers. Every provider, for example, you can run GPT 3.5 on OpenAI or on Azure. That means a single model can run on 2 providers. Every provider, for example, Azure, can run Llama, can run GPT 3.5. So many-to-many relationship. Model can have many providers, provider can have many models. How do you create many-to-many relationships? You do that by creating a third mapping table where you describe this model and this provider ID are linked, which means this model can run on this specific provider. This should not be a float. It should probably be an integer. Not the best idea to store floats in the database. We'll probably store, cost per million tokens, which will almost always be an integer. Or, we can store something else. Cost. This can be, cost per 1 million tokens into a big number so that it always remains an integer. But whenever you're doing any financial transaction, which we will based on this output cost and input cost, it makes sense to not use decimals and use integrals everywhere, even if you have to pad the cost a bit. Even if the cost is, let's say, 0.01 dollars per million tokens, it makes sense to store 10 in the database. That means just multiplied by 10 and eventually divided by 10 whenever you're debiting the user's balance, so that you don't run into precision errors, which is a whole different discussions. But to keep it short, whenever you're dealing with money, the credits that the user has, which is this thing right here, should be an integer. You might think, Harkirat, how can this be an integer? I might on ramp 399.99 rupees. And the answer is, again, there are a few answers here. Number one, if the user on ramps with 399 rupees, that will translate to like 10,000 credits that they get. That is what this number represents. This credits number does not represent the dollar value or the INR value the user has. It represents a very big number compared to that dollar value, some multiplier. So we can say for 1 rupee on ramp on our platform, you get 100 credits, and that way the amount that they on ramp will just be multiplied by 100 everywhere, which would always be an integer. And when we debit these credits as well, we'll ensure the debiting that we're doing based on this input token cost. This input token cost will be in whatever dollars per million tokens. We'll convert that to our credit system and then only debit the user. This is to ensure, if we have multiple currencies in the future, if you support not just dollars but INR, then if a user on ramps via dollars, then they might get, let's say they on ramp $10. If we put 10 over here, then in the future if they on ramp 10 INR, then we might just end up making it 20, which is why it makes sense to have a single credit system irrespective of the currency the user on ramps in. Even if the user puts in $10, we give them 1,000 credits. If the user puts in 800 rupees, which is like closer to, or 900 rupees, which is closer to $10, we give them 1,000 credits. So the number of credits you get is going to be the same irrespective of the currency that you're putting your money in, based on the current currency conversion prices. Great. That covers the three many-to-many relationship tables that we had created. On-ramp transactions is just, a razor pay specific endpoint that'll, whenever the user actually pays us some money, we'll put an entry here, just so we have an audit log of, when the user tried to initiate a transaction, when did their transaction actually succeed, so on and so forth. And lastly, the main table, the conversations table, where we'll store all the conversations that the user has been doing, and which API key they used for this specific conversation, and which provider was the request eventually forwarded to, which model did the user intend to use. So the model ID will be provided by the user. That also reminds me, when the user does provide model IDs, they don't really provide model IDs. If you look at OpenRouter, what they provide is, like a model slug. So if you look at the docs, you will see the user is not expected to give us an ID. What they're expected to give us is something like this. So the user will give us like a small slug for the model that they want to use. This slug should also be stored along with the model over here, so that it's a more human readable slug that the user can provide us, rather than giving us an ID like 1, 2, 3, because they don't really know what ID a model has in our database. So it makes sense for them to specify a slug. It also makes sense for us to store that slug in the database whenever we're adding more models. Like eventually there'll be an admin dashboard where people can add models from. We'll get there when we get there. Basically, we'll just seed the data in the database. But whenever you're adding a new model, the thing that you might add over here might be GPT-5 by OpenAI. But the thing that you add over here is going to be whatever, OpenAI/GPT-5, whatever is the slug that we support on our platform. All right, I think that is the right schema. I could totally be wrong. I'm probably missing a few things here. Feel free to visualize this on some sort of a Prisma visualizer and get comfortable with it. This is like a good point to take a pause. If you feel like you've never done full stack before, then this might be a little challenging. But if you've done full stack before, hopefully this diagram sort of makes sense to you. Feel free to paste the schema over here and visualize the whole thing a little better, even though what you see over here is the same thing I wrote on Accelerator a while back, which is a bunch of tables. The only other thing that you see over here is slightly better relationships between the tables. So feel free to go to prismalizer.app and visualize the full database on your side before you proceed. This is what it looks like: a users table, a models table, this one right here, a providers table, this one right here, many-to-many relationship between both of these, on-ramp transactions table, conversations table, API keys table. Beautiful. Covers the schema. Ideally, again, I'm going to write a bunch of the code myself, but if you know things well, if you understand things well, you can actually create a decent bunch of CRUD endpoints using AI here. That's what I would do if I had to move really fast. I won't do that today. I'll at least try to create the first few endpoints by hand, and then we'll see where we go. But that's not the worst way to approach a problem or create a product initially, as long as you're making the AI write clean code. It's not the worst thing in the world if you've written the schema and checked everything makes sense. You can actually expose a bunch of CRUD endpoints using AI. You just move faster. We will not do that though. The next section, now that we have created the schema, let's start to write our primary backend. Let's start to write our primary backend. That is this one right here. Index.ts is completely empty right now. It looks very lonely. So we'll start to write all the CRUD endpoints that we want to support. So I'll probably just list down everything that I think we need for an application like this. And once that is done, we'll start to write all of those endpoints one after the other. I'll see you guys in the next section. All right. Today we're going to do two new things. Number one, we're going to use ElysiaJS as our HTTP framework. I've heard great things about them. I've always wanted to try it, so this video gave me another reason to do it. Number two, we'll be testing all of our HTTP endpoints using the software called Requestly. They're also the sponsors for this video. And they let you test HTTP backends easily using the GUI. They also let you do a bunch of other things, which I'm curious to try eventually, intercept and modify web traffic. So I'm assuming this is similar to Burp Suite, but that's not what we're going to do today. What we'll use is their API client that will let us send HTTP requests to the backend that we're creating to test it. With that, we'll kick things off. If you remember where we left off, we have a primary backend that we're supposed to build now, and we'll not be using Express. We will use a new framework called ElysiaJS, if I'm pronouncing and writing it correctly. Let's go through their docs and probably a quick start. This might not do it because I've already initialized a backend, but for all practical purposes, I can actually go to apps, get rid of the primary backend, and initialize a new Elysia app, which it initialized in a folder called app that I'm going to move to a new folder called primary backend. Let's explore what we get there by default. If I open primary backend, I get a source/index.ts, which looks like a basic HTTP server. Let's see if it does what it's supposed to do. If it starts listening on port 3000, and if I send it a GET request on the landing page, it returns me hello Elysia. Let's do a one.index.ts. Source/index.ts. Let's go to Requestly. Let's create a new request to http://localhost:3000. And what I get back is hello Elysia as expected. The routes that we're going to write today are going to be a sign up endpoint, basically all the auth routes. Might be a good idea for us to list them down. So we're supposed to write a bunch of auth routes that will be sign up, sign in, a bunch of API key endpoints. So create API key, get API key, delete API key, disable API key. I think 4 of these. Anything else for the user? Probably model specific endpoints. So get all the supported models, their pricing, etc. Pricing providers, etc. If we create an admin dashboard, it might make sense to put a bunch of admin endpoints as well. But right now, I'll probably just dump the things that we need in the database. I'm sure there are things that we're missing here. Let me open the schema ones. API key. All of these can actually be oh yeah, all the on-ramp, off-ramp endpoints. So all the payment endpoints, which will basically be, Razor, Pay, Stripe, something like this. So we basically need 4 high-level, routes to support. Let's start off with writing the auth routes. We can write everything in the same file, usually not the best idea. Hence, I'm going to create a folder structure recommended by these guys. There was a best practices section that I saw. It basically says create a modules folder inside which you add your individual, services. I'm going to do the same modules followed by auth and then API keys, models, and lastly payments. Let's kick things off with auth. Let's add a index.ts, model.ts, service.ts. They recommend 4 things. Let's kick things off with index.ts, which probably, yeah, it's just going to have all of our routes written down. So it's import Elysia, oh, how do you spell it? Elysia from Elysia. Export const app equal to new Elysia. Prefix is probably going to be auth for us as well, because these are all auth routes, followed by everything that we support. So a post endpoint to /sign up, and then the handler, which the handler followed by the type and the things that we support in the response. That sounds good to me. Yeah, that sounds good. Are they using the body, the session? They are. I'm unsure if we're going to use cookies or not. Let's say we do use cookies, even though I'd like to use JWT generally, which I think they might have a section on. A sign up endpoint with a function handler, and then a sign in endpoint with a function handler as well. For sign up, what we want is we want to hit the database to check if the user already exists, so on and so forth. The first thing we need is the body. So how do you get the JSON body here? Seems like it's as simple as extracting body. And we do want our body to have a specific type, which we can specify here either using Zod, or in this case, they've written the types in the auth model. So let's create a similar namespace inside which we will describe our sign up and our sign in body, as well as response types. You might ask, Harkirat, why are we specifying the response types? And the reason is, if we do specify it here, we might get end-to-end type safety when we're writing the front end. We might be able to infer a lot of these from the front end as well, on the front end as well, which will make our front end development a little easier. That's the whole reason to do such strict typing throughout our application. These are all things that you may or may not need in your application, but I just wanted to create a little more type safe application. It doesn't have to be this type safe at the primary backend layer, but let's just do it. Export namespace auth, or let's see what they named it. Auth model sounds like a good name for it. Const, let's see, we need the sign in schema equal to t dot object. This is me providing the schema for the input. Whenever the user signs in, they're going to give us a username, which is going to be a t dot string, followed by a password, which is going to be a t dot string. Now, ideally, you probably need an email. Let's see what we're storing in the schema. The user has an email and a password, so that's what we're going to use as well, email and password. And you can also export the type of this sign-in schema. Are they using the same names? Sign-in body, sign-in body. They are. Okay, I don't mind that. I would rather name it sign-in schema though. Sign-in schema type is going to be infer the type of sign-in schema. What this will do is it will export this type object, and it will also, when I say type object, I don't mean a type. It's basically an object from this, t create, which I'm assuming means type create in Elysia, and the sign in schema, which is an actual type, which looks as we'd expect in email and password. That's the sign in request schema. We need to write the sign in response schema as well. What do we expect to return to the user when they sign in? We probably need to return them a token, which is what they return here as well. I don't think we need to return the email. Let's call it sign in response schema. I don't know what they've called it here, sign in response. I would like to have a schema in there, and also export type sign in schema, or sign in response schema, my bad, equal to type of sign in response schema dot static. Again, the same thing. This will export a type which is inferred from this more coherent runtime object. That's sign in. We also need the same things for sign up, which surprisingly might look very similar. For sign up, the user will have the same inputs, but the response can be a little different. Sign up response is going to be just their user ID, I think, which is the ID of the newly created user, and that's it. Yeah, that should be good enough. Now, coming back to the model, sorry, not the model, the call it the controller. This is not even the controller, it's like the route creation file. The body is going to follow auth model dot what was the type again? It was sign in response schema, or this is sign up, right? So sign up schema, this thing right here. This is the body. Even though it gives me a type error here, auth model dot sign in body. So that's the, is that the type? What does it expect here? What does Elysia expect here? It might expect the type. So this is what we might need. That is wrong. Does not exist on type of auth model. Auth model. Oh, I did not export this. My bad. Export, 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 and export. That should do it. There we go. That's the body we expect, and we can also return the responses, which would be either a 200 status code with this specific schema. Beautiful. In our case, sign in response schema, or a 400 with probably like a bad message. I don't know what they've done here. Sign in invalid. They also have a type for that. T.literal invalid username or password. I'd probably have something else. So sign up response schema export type sign up failed responses schema equal to type of the same thing, and I define that as well. Export const this thing equal to, again, I'd probably stick to an object rather than a literal, with the message that says error while signing up. Z.literal or T.literal error while signing up, and that is what needs to be stored here. Auth model dot. So it's like extremely verbose, very close to Java. I would say it feels like I'm writing out of Java. It's not the worst thing in the world. Sign up. So where probably a service.ts would come in, which will tell you what actually happens when you sign up. Yeah, there you go. Which surprisingly, they have a class here. I don't know if that's the best thing. If a class doesn't need to store a property, you may use abstract class to avoid class allocation. Could be a function, could be an abstract class that supports static methods. I think either is fine. If this is the practice they support, might as well add the same thing. So add a new file here called service.ts, export service.ts, export abstract class, let's call it auth service, basically the same as these guys, which is going to export a static function called sign up, which will take a username, which is a string, a password, which is a string, and hit the database. The same will be true for sign in, and should probably return the user ID here. So a string should probably return should probably return a token here, so should be a string as well. When you sign up, you basically need to do a bunch of things. You need to check in the database. Actually, this might be an async function. The same is true here, and this might throw an error, or we can, or a rejected promise, either of the two. If things go bad. So what do we need to check during sign up? The first thing we need to check is, ideally we need to check, does the user with this email already exist? The good thing is we've made email unique over here. So the database call will fail if a user with the same email tries to sign up twice. So all I can do is await. Now this is where I have to do some more Prisma stuff. So I'll just leave it as is for now. Then we'll get into the Prisma stuff. I will come back to, I'll come back here, const user ID equal to auth service dot sign up. I would await this and then simply, I don't know, return probably. What was the schema again? Sign up response schema, not sign in, it should be sign up. Yeah, ID. So something like this. This should be async. Body declared value is never used. Body dot email, body dot. Look at the type safety here. We love that. And still an error. Not assignable. I don't know if you have to do supposed to do something else. You're simply supposed to return it. I think sign up schema. Oh, this should be sign up response schema and not sign in response schema. The same thing is true here, and beautiful. Do you see the benefit of type safety? I don't know if you do, but I do. Sign in is going to be very similar. We have to define the body, which is going to be auth model dot sign in schema. The response, which probably is going to be a 200 if everything is good. So auth model dot sign in response schema. But if things go bad, it should be a 403. Auth model dot sign in failure schema, which would be defined here now. Export const sign in failure schema equal to t dot object. Sign in failure schema should probably return the user a message that says something like incorrect credentials, literal. That's sign in failure schema, and then export type, same thing, equal to type of this thing dot static. Beautiful. That should do it. The body is going to look very similar. Const token in this case equal to await auth service dot sign in. With a body dot username where body comes here. Email and body dot password. Beautiful. Return the user their respective token, and I think we're good to go. Incredibly verbose writing the sign up and the sign in endpoint, but I think we're here. Let's test them out soon enough. Let me just, for now return a string over here that's, user ID 123. For now return a random token over here, token 123. And let's wire it up. Let's see, does it actually work or not? I'm exporting the app from here. I'll go back to the root index.ts, import app as auth app from modules slash auth slash, that's good enough. And I don't know how you hook this up, but if I had to guess, it'd probably be this. Let's see. I think that should do it. What we've done is any request that comes and starts with a slash auth, and probably, if it's a sign up request, so it's slash auth slash sign up, a post request should come here, a slash auth slash sign in should come here. These are all assumptions. Let's see if they're actually true. Let me go back to requestly, do a slash auth slash sign up, and not send any, that's why, body, send some JSON body that looks like this, username, or sorry, email, harkirat@gmail.com, password 123123, send, and I get a 404. That's most probably on me. Auth app, prefix auth, /sign up. Would have oh, it's sign dash up. My bad. Send it now. And returns ID 123. If I do a /sign in, returns token 123. If I send it the wrong schema, I'm just curious to see what comes back from Elysia. Gives a very nice object that probably tells you what went wrong. In this case, it's telling you it expected these two things, found password errors, expected property email to be a string but found it to be undefined. Beautiful. We get a lot of type safety, which you get by default in more type safe languages. But here, you're getting it out of the box. Now that we're using Elysia, beautiful. Sign up and sign in work. The only thing that's left now is hooking up the database. The auth service is sort of hard coded right now. That means in the next section we're going to do a little more things with Prisma, set up a database, migrate the database, generate the client, import it over here and use it. The next step is going to be, now that we've created a boilerplate Elysia application, actually hooking it up to the database, completing the CRUD functionality for sign up and sign in. Let's get into that next. Right. The first thing you have to do now is create a new database. Effectively, whenever you're using an ORM like Prisma, there are a few steps before you can actually start to use Prisma in your project. The first step is actually creating a database. You can create one locally using Docker. You can install Postgres locally on your machine, or you can get a cloud instance for now for free. If you go to neon.tech, let me create a new database called OpenRouter. And let me copy its connection string, which is basically this thing right here. This represents, the credentials to be able to connect to this free database that I have. If you look at it right now, this is an empty database. If I open the tables, I basically don't see anything. Because this is a fresh database, there are no tables in here. The next step is converting this schema that I have written over to actual SQL tables, which is also known as creating a migration. Before that, I have to replace the Postgres URL present over here with my neon DB Postgres URL. There are also a few instructions over here that are helpful that we'll eventually come to. And the next thing I have to do is run the command. I think bunx prisma migrate, or we can just follow the steps over here. We've done until this point. We have updated our schema. The next step is running this command, bunx prisma migrate dev, and giving this specific migration a name. Every migration that you do, every time you change your database schema, you have to specify what you're doing, just so it's easier for future developers to see. Init, since I'm initializing the schema for the first time, is a good name for it. When I run this command, I'm running it in the wrong folder. So if I go to packages /db and run this command, I get an error. Cannot find .env config from here. I probably have to do a bun install. Try it again. Same error. Let's see. db / I do see a prisma.config.ts. I do see this one add .env / .env. Let's try it now. I would have expected this dependency to be there. It wasn't for some reason. Bunx prisma migrate dev -- name init should migrate my database now. We saw 0 tables over here, but running this command should actually put, whatever, 7, 8 tables, the tables that we've described in our schema.prisma file. Let's wait for it to happen. And we get an error that you'll see from time to time, depending on what Wi-Fi you're on. Let me change my Wi-Fi. I've seen this a bunch of times. Connecting to a VPN helps usually. So let me change my Wi-Fi and try it one more time. If this doesn't work, then there's a serious problem. Looks like the right database it's trying to connect to. That seems to have worked. The only thing I did was I changed my Wi-Fi, and I've seen this with Neon from time to time. If you do see it, you can run it locally. You can use a different service like Avian to run it. But most probably, if you try 2-3 times, it should just work. What this command did was it generated the actual SQL queries to create a user table, to create an API key table, to create a company table, so on and so forth, and actually applied the migration here, which basically means now I have a table that is actually migrated that has an API key table, a company table, a conversation table, so on and so forth. My DB is migrated. The next thing that you do is you generate what's called the client in Prisma, Bunex Prisma generate. What this does is it creates this generated folder. When we say generated, it basically is an auto-generated folder based on, again, the schema.prisma file. Based on the schema.prisma file, it created a bunch of helper TypeScript files for me. Things like, user.ts, which exports everything I need to connect to the users table. API key.ts, which contains everything I need to connect to the API keys table, so on and so forth. These auto-generated files are what I now need here in my primary backend, because from the primary backend, I need to connect to my database. This is like general turbo repo structure. This is your end user applications. This is a package. In this package, I need to now export the Prisma client that I can use in my primary backend and in the future in my API backend as well. To do that, you can, they pretty much make it a little easy specifying how you can do that. Import Prisma client from the generated folder, import Prisma PG from their PG adapter because we're using Postgres, create a new adapter and create a new Prisma client and export it. This should export the Prisma client. This Prisma client that we're exporting from here has functions like prisma.user.create that lets me create a new entry in the users table. Prisma.api key.find first that lets me fetch an API key. The job of an ORM is to make our lives easier when we're trying to interact with the database. It lets us interact with the database without knowing SQL. That's exactly what an ORM does. It has exported a Prisma object for us. To be able to import it in the primary backend, I need to go to package.json, and this is turbo repo stuff. Okay, if you go to package.json and add a new exports section, and you export dot slash index.ts under the root route, what that will do is, if you go back to primary backend and in its package.json add db as a dependency with the version, as a dependency with the version set to star. That would mean I want database as a dependency, but database exists here in my packages. What this line of code does is, this is usually for adding dependencies. For example, we've added Elysia as a dependency, we might add JWT as a dependency, Quartz as a dependency, maybe Mongoose as a dependency. We don't need any of those. What we do need is this database module that we have created. Whatever it exports, which is this Prisma object, I need to import over here in my primary backend sys files, specifically, source/modules/auth/service.ts. Here I want to use the Prisma client, and hence to my primary backend package, I've added the DB as a dependency. If I do a global bun install now, and when I say global, I just mean in my root folder, I can now in my service.ts import the Prisma client from DB. This gets tricky from time to time. As you can see, it's not working. Cannot find module DB or its corresponding type declarations. So I'll go back to the package.json here. The name here is indeed DB. I have added an exports section. I don't know if it's export or exports. The one more thing I can do is I can export everything in index.ts under the /client subroute. So when I import here, I will import from db/client. That is what I was missing. The thing that you're exporting here, I think you can export it at a root level as well, maybe something like this, because we don't want to export anything else. Yeah, that works. This was what was incorrect. I want to export at the root subroute everything in index.ts. That way I can import Prisma from DB over here. The Prisma client that I generated, the database logic that I ran, the migration that I did, the client generation that I did, and the file that I had created, all of this led to me having access to the Prisma object here. And now when a user signs up, what do you want to do? Prisma.user.create. You want to create a new user with this username and then this password. I think it might be an email. I don't know why I named this username. And I hope here also I'm using email. That is correct. Prisma.user.create email const user equal to this thing. And then once the user is created, we can return the newly created user's ID. Number is not assignable to string. So one thing I have done is, I think all the IDs are numbers and not strings, which is not great. Ideally, they should be UUIDs or strings, but that is fine. What that will do is the sign up function will not return, promise of string, or what you can do is just convert it to a string. What we return to the end user is their user ID in a string format, but we can also return it in a number format now that we're storing it in the database as a number. That's the sign up endpoint. That's all you need. The only thing is, this might throw an error if a user with that email already exists. So ideally, we should catch that error here. Ideally, we should catch that error here. And if there is an error, we should actually return a 400 status code with this response schema, with the message that says, whatever, sign response schema. This should be sign up failure response schema, which looks something like this. Message that says error while signing up. So what we want to return here is something like message error while signing up. And how do I specify the status code here is a good question. I will have to go back to the ElysiaJS docs and figure out how do you return a bad status code. Return status of 401. Let me just search through this. Custom status codes. That sort of works. Return status of 400 comma error while, or actually something like this. As you can see, if I just give it the string literal, there's a type error here. It says, you didn't specify in the failure response. The failure response schema looks like this. You actually said it looks like this. Now I would have hoped for the type error to go away. Message literal error while signing up. Message literal error while signing up did not work. Let's see. Got the error. Status is what you have access to here, and you don't import it from here. That was the error. Status is what you have access to here in the request, whatever function body itself, and you don't import it globally from Elysia. That was the error, and that should finish the sign up endpoint. Let's quickly test the sign up endpoint. Let me do a bun index.ts cd apps / primary backend bun index.source / index.ts. If I go back to requestly, and if I do a send here, the first sign up, sign dash up, the first sign up for this email gave an error. I don't see any logs here, which is not great. I get a message error while signing up. I can actually log the error that came. Let me try sending this one more time. And the error is connection refused. It's probably trying to connect to the wrong database, probably like localhost. And I think the way to fix this is if you go to the .env file, it actually tells you environment variables declared in this file not automatically loaded by Prisma. Please import to your prisma.config.ts. So if I go to my prisma.config.ts, I have imported this. I think I have added these as dependencies as well. I would have hoped that would have done it. Let me try that one more time. Let me go back to packages /tb. Let me do a bun generate, bun x prisma generate. Let me go back to apps / API backend. I mean, there is a easier solution to this, which is I can create a .env file here and also add the database string here. Let me try bun dev one more time, or whatever, bun source / index.ts. Oh, wrong file. primary backend v.env. What I've done is I've created a .env file in primary backend /.env as well. Because what might happen is, even though I don't think it should happen, even though this is fine, the primary backend is the one that's orchestrating the DB layer. It makes sense for it to have a database URL over here. Let's try doing bun source /index.ts. Let me go back to request leak, send a request, and it's waiting for a response, sending request, waiting for a response, taking a long time, but eventually I do get ID1. Why did it take so long for the request to go? Because we're actually connecting to a database that's on Neon, which is a serverless database, which is probably sleeping right now. It took it some time to wake up. Now, if I sign up with another user, I do get back ID 2, I would assume this time. There we go. So on and so forth. You might think, how can I make it faster? Just don't use free Neon. Use like a paid database, manage your own database, so on and so forth. If I try to sign up with an email that already exists in the database, now this entry has already reached the database. If I refresh the users table here, you will notice I have 2 entries and do have an entry for harkirat1@gmail.com. If I send this again, I hope to see an error message with a 400 status code. And what do we get back? A 400 status code along with a message that says error while signing up, which is great. These are the 2 states that we support. If the user does sign up with an email that already exists, we return them this message. If the user does not, if the user signs up with an email that does not exist, we give them a 200 status code. That finishes the sign up endpoint. The next thing we have to do is create the sign in endpoint. I'm hoping that's straightforward here. If I go back to the auth/index.ts, we had implemented we are supposed to implement the sign-in logic here. What do you think should happen? I mean, the first thing that should happen is you should probably hash the password before you put it in the database. I hope you guys understand what hashing passwords does. I think bun has something that it provides, .hash. The password, bun.password.hash should be able to hash the password. This might be an async function, so let me just await it. This would make sure the password that actually reaches the database is a hashed password. And similarly, what we need to do on the other side during sign-in is we first need to find if a user exists with that email. So const user equal to await prisma .user.find first, where this specific user with this email exists. And if they do exist, if user does exist, then what we're going to do is we're going to match their password, const matched equal to bun.password.verify the 2 passwords, the one that the user, okay, what arguments does it take? Password and hash. So the original password that the user gave us and the hash that came from the database, which is user.password. This would actually tell us if this is the correct password or not, if the user has sent us the right password or not. Why are we not storing their password in plain text in the database? It's a standard practice. You should always hash passwords before storing them in the database. There are many reasons to do it. I'm not getting into that. If that is true, the user gave us the right username and password, we should sign a JSON web token and return it to them that they're going to forward us in all the subsequent authenticated requests. Else we can just throw a new error that says something like, incorrect credentials. If matched, we need to sign a JWT for them. There are many ways to do it. I would like to look at how these guys prefer you creating a JWT. And it looks like ElysiaJS has its own JWT package, which we're going to use, which we're going to first add as a dependency. So bun add at ElysiaJS/JWT. And once that is done, the way to sign or create the JWT is JWT this. Okay, they make it a little hard, don't they? Cookie auth. Okay, this is not standard JWT. This is JWT with cookies, which honestly is fine. So yeah, what the controller should probably then do is just return a boolean if this user correctly signed in or not. So if user and this return true, else return false. That's all we should do. Ideally, I'd like to like this a little more cleaner. If not user, return false. If this thing, if not this, return false, else return true. It's like a standard, pattern called early returning. And now sign in will only return you whether or not the user has sent us the right credentials. So what variable name should I give here? Always a tough choice. Correct credentials equal to this thing. If correct credentials, then do something else. Pretty straightforward. Return them a bad status code. So something like 403 with whatever sign-in failure response looks like, which is simply a message that says incorrect credentials. So this part is fine. If they did send us the right thing is when do we want to return them a token in the headers or do we want to return them a JWT in the body is the question. Basically, if you're using cookies, you return them the JWT in the headers. It's like decentish practice to use cookies, so I don't mind using cookies, but here is a common conundrum around do you want to use cookies or do you want to use JWTs plus local storage? There's no, like, both are fine, I guess. Like, there's no pros and cons there are pros and cons, but doesn't really matter for most applications. Let's go with cookies for our application. What we're going to do is we're going to accept cookies over here as a third argument. And again, these guys make it a little easy for us to write, cookie logic. So there is an auth cookie that we want to, update over here, auth.set. And in this case, what we do want to set is, this should actually return the user's ID. The thing is, yeah, it's supposed to return not just a Boolean, but also the user's ID that I need to sign over here. This is not needed. This is fine. HTTP only is fine. The value needs to be, whatever user ID I got from here. So ideally, what this should return is signed in Boolean and user ID, which is a number or a string, doesn't matter, but yeah, string is fine, I guess. So what we're going to do is return is signed in false, or correct credentials false, and user ID needs to be optional. Here I'll send the same thing, correct credentials false. Here I'll send the same thing, correct credentials false. Here I will send correct credentials true, and the user's ID, which is going to be user.id dot toString. Now that that's done, what I'm getting here is not just one thing, but two correct credentials and user ID. If correct credentials and user ID exists is when we want to go down this route. And what we're going to do now is set the cookie to be this user ID. And we don't have to return anything now. So the sign-in response schema can actually be fairly empty. You're just returning them a header that returns them their JWT. So ideally, we don't need any schema here. But I'd rather just add a message here that says signed in correctly, something like that, successfully. And I'm going to return the same thing over here. Beautiful. There's an error here. Auth is possibly undefined, it says. If there also is this middleware that we need to add. Name JWT secret. So what we want is a few things. First thing I'm going to do is add this middleware dot use JWT, which probably comes from here. The secret is going to come from our env file, process.env. I still need to know what this name is. .jwt underscore secret. Go back to .env in primary backend, add a JWT secret for now. Tell TypeScript it indeed does exist. And the sign in endpoint, don't of course send the user's user ID in plain text. Just send a jwt.sign user ID. It says sign does not exist here because JWT will get access to here. I guess I could be wrong. The name field over here represents how you will get access to the JWT object here. So if it's JWT here, JWT here, beautiful. I think JWT is fine for me. This actually, if you're coming from the Express world, it's really hard to pass objects from one middleware to another. And in ElysiaJS, it's much easier. Just specify the name over here. You'll get access to it over here. Now comes the last part. Auth is possibly undefined. We probably should do something like this. If not, auth equal to new cookie. With a bunch of things. Why don't they see the error here? Because auth will probably be undefined initially. Cookies auth. Yeah. By default, comments pass set cookie inherits value. Name secret. Oh, I think that is already there. User ID is fine. Okay, how do you initialize a new cookie here? That's not going to be very easy. Name was not provided. Let's say I name it auth. And the second one, jar was not in my. That is not going to be easy, but okay, I think that should do it. Value is going to be the JWT value. All right, I've done a few things. What I've done is, I think I've created the sign-in endpoint. The first thing it does is it checks from the database, is everything good or not? Was the user able to sign in or not? If not, then simply return a 403 status code. If everything is good though, then create a new JWT for the user. Let me just rename it to token. And set the user's auth cookie. So you can have many cookies, one for auth, one for user preferences, dark mode, things like these. Specifically the auth cookie, we're initializing to a new cookie if it doesn't exist, and then setting it to be the specific value with a few, cookie specific parameters. When does it expire and whether it's an HTTP only cookie or not, which generally true is a good idea. Let's see, does it work though? So if I do a bun source/index.ts, and if I go back to requestly and send a sign-in request now for a user that already exists in my database, let's see what response I get back. The response I get back is password verification failed, unsupported algorithm. A few things went wrong here. One, you should never return a 500 status code from your backend. That just tells users something went wrong in your backend, which you should try to hide as much as possible. Two, seems like that's not how you use bun.password. I was using, hold on, I know what's wrong. The existing users that I created, I had only password over here and not a password hash. Now we're hashing the password and storing it in the database. So let me create a new user for which the password is actually hashed. And now when I try to, is the user created? Yes. Is there ID 4? Yes. If I sign in for this new user now, it does say message signed in successfully. And if I look at the headers that I got back, one of the header is a set cookie header with the auth token set to this, which I would like to actually see if it actually decodes to what we want. It should ideally decode to my user ID, which was 4. So if I go to jwt.io and try to decode this JWT, what I see is user ID 4 issued at this timestamp, which is beautiful, exactly what we wanted. We're not storing or getting from the backend the token or the JWT in the body. You can do that as well if you want. That is the local storage plus JWT body approach, which I was talking about here. But what we want is what we're using is the cookie approach, in which case the thing we need to confirm is, do we get a set cookie header from the backend or not? In this case, we do. And hence, for all future requests that our browser sends eventually, it will send this cookie, and our backend should be able to verify this cookie and give them access to the authenticated endpoints. That covers the sign in and sign in endpoint. Seems to work as expected. If I sign up as the new user, the request goes, and I get back a 200 status code. If I try to sign in as that user with the right credentials, I get back a 200 status code. And the bigger thing is, if I look at the headers, I do get my authorization header over here, which I can use for all future authenticated requests. That covers the sign up and sign in endpoint. Next up, what do you think we should do? I don't know. We should probably start off with API keys. That's the simpler one. Let's hash it out really quickly. Let a user create API keys, fetch their API keys, disable an API key, delete an API key. Once that's done, we can go to the rest. Let's do the API keys next. Alrighty, things should be fairly easy from here. Inside API keys, I'm going to now introduce the same three set of files: index.ts, models.ts, service.ts. I'm going to define a new app inside index.ts, new Elysia dot post. API key, you can create one, and I think you have to add something here like a suffix, prefix. API dash keys. A post endpoint should do a few things. A get endpoint should return you all of your APIs, probably should be paginated. Post get, there should be a post to disable. And then there should be a delete request to delete a specific API key of yours. That should do it. Looks good to me. Now comes the database part, which should be easy enough. Oh, before that comes the authentication part. We expect the user to give us or send us, a cookie, which means a header. If they don't send us an authorization header, that is right. We need to reject that specific request. How you do that in Elysia, we will explore together. That's how you add a GWT. How do you verify one? Okay. Seems like it's as simple as that. Dot use the same thing here. Name GWT secret would be process.env.jwt underscore secret. And this should come from ElysiaJS. In the first post endpoint, well, in all of them, we need to do this. I'm hoping there's a way to abstract this out above in another middleware. Seems like they don't provide a good example for that. The next thing we need to understand is how to create middlewares in ElysiaJS, which again, I don't see a very good example for. So let me just go through their docs and figure out how can we create a generic function that gets called first. So most probably is going to be something like this only, a function in here that first checks the cookie, and then if the cookie is incorrect, rejects the request. If it is good, is when control reaches here. And we'll probably just reuse this middleware across. So we probably have to create a middleware of our own. Most probably we'll have to create a middleware.ts file where we'll define our Elysia middleware and then just call .use middleware, similar to what's happening here, or let me call it auth middleware. How do you write one in ElysiaJS is something we still need to figure out. So let me just spend some time figuring that out.
A few moments later.
All right. I was able to figure it out. To be able to create some sort of a middleware in Elysia, you can use resolves. If you look at the documentation, it appends a new value to the context, which is exactly what we want. We want a user ID to be present here in the context, along with, whatever, the body that the user might be sending, so on and so forth. In order to do that, to append something to the context, what you can do is use these resolves, which in our case would extract the cookie, the specific cookie that we need, which is the auth cookie. If it doesn't exist, return a 404 status code or a 401 status code or a 403 status code. If it does exist, then verify that it was indeed signed by us, during the sign-in process. If that is not the case, return a sort of status code of 401 again. But if everything is good, then return user ID as, whatever is the decoded user ID that we had signed during the sign-in process. So when you're signing in, this is what we sign. And when you're hitting any authenticated endpoints, these tokens get verified over here. And when you say return user ID, this doesn't get returned to the end user. This gets forwarded to the next route in the chain, which in our case can be this post, this get, this post, or this delete. Ideally, this whole thing should be abstracted out somewhere else because we'll reuse this in 10 different places. We'll just have to figure out what, the type of that function needs to be. I think context might do it. So let's just do that right now. Let's call this the auth middleware or something. So if I go to, again, a middleware.ts file that I deleted, let me define a function called async verify token, something like this. Export async function verify token. Yeah, again, the return type here will be very tricky, but I think if I write context here, things might fall into place. Yeah. This will be a little tricky because of just simpler type inference. What I can do is I can actually expect these as arguments. Something like auth cookie, which is a string, then JWT, which is just this type might be tricky. Something like this verify token. Again, I am abstracting this out because I really want to use this function in multiple places. And JWT, unfortunately, and status as well. The reason I say unfortunately is because it will be very hard to figure out what types these hold. So status has a type of, something that comes from here, which I don't see a very easy type for. Is that it? That does not look like it. Yeah, it might be really hard to abstract this function out and use it across various files. Let me delete it for now. We can figure it out later. And let me re-add the logic here. I've still not tested it, so let's test it out really quickly. What do we expect in the body of a post request for creating an API key? Just a name for the API key. So let's go to models.ts. Let's export a namespace called API key model, inside which I'm going to export create API key schema const equal to this would be again t dot object of t dot name for the API key, t dot string, export type same name equal to type of dot what was it, static, I think. Yeah, that looks fine. That's to create it. What are the other endpoints we support? Get is probably pretty simple. Disable will get the ID. So export const disable API key schema equal to t dot object, which would get the ID of the specific API key to disable. So t dot string, that should do it. And again, export type this thing equal to the same thing dot static. No, type of that, my bad. And then lastly, delete, maybe we can just have a parameter, which is the ID that the user wants to delete. And that's it. That should probably do it. We also have to describe the response types. So export const create API key response. They should probably return an ID of the newly created API key and the actual secret. So this will be a string, and so would this. The what did we call it here? I think we called it a API key, so I'll just call it same dot string, and we might need this, yes. And disable API key should probably just return a simple message, honestly. So we don't really need a response schema here, but let's just create one. Message t dot literal disabled API key successfully. What else? There is get API keys. This will be tricky. Export const get API keys response schema equal to t dot object. What do users expect when we return them their API keys? Just the name, which will be a string, and then I mean on OpenRouter, I think you can't see all your API keys. At least they're secrets. You probably see like some partial version of it. Let's open OpenRouter and see what do I get whenever I open the API keys page. Yeah, I see some part of the API key secret as well. Expires last used, something we probably should add. Usage is nice. And limit. They have a bunch of things. We don't support everything yet. At the very least, we need to return, some part of the API key. So API key is fine, even though we're not really returning the full API key, just a part of it. And eventually, we probably need these. Last used actually would be nice. T dot string. But if you do want to support this, we'll have to change the schema a bit and store last used date. And at default to now, but even though if you really think about it, unless it is actually used, we shouldn't right now. So I would just make it optional. Last used, I think it's date time. Yeah. Yeah, we should add this field so we're tracking how often was this used. Ideally, we should also track the credits usage here. So something like this, credits consumed, which will be probably just a number. So an integer, which will default to 0. Whenever you change your schema, you're also supposed to migrate your database. So let me go back to packages/db and migrate my database. It basically means letting the database know that two new fields have been added, last used and credits consumed. Based on this, we can also return, credits consumed to the front end, and then the dollar value that they've consumed is just a function of the credits. If they've spent 2,000 credits, that's probably, somewhere around $10, $20, whatever our conversion rate is. All right. These are the 4 things that the user expects to be returned to them. Beautiful. What else do we support? Disable API key, which should just, again. Okay, disable is already here. Delete API key is the 4th one. We probably need the schema for that, even though again it's just as simple as a message. Okay, a few things are wrong here. This should probably be this, and all 3 of these should be delete, and the message should probably say API key deleted successfully. All right. I think that covers all the types. Now let's quickly finish the routes and let's see, did our database migrate? Indeed it did, which is beautiful. After you migrate the database, you're also supposed to regenerate the client, so it has all the new fields. Now we're good to go. Apps/primary backend. We're getting there. The post endpoint, as simple as creating the API key. So I'm going to now go to service.ts and export abstract class API key service, static function, async function, create API key, which will take a name, which is a string as an input, and probably return an ID of the newly created API key. Think, I don't need to write function here. What I need to do here is const API key equal to await Prisma dot API key dot create name. What does an API key have? It has a name, a user ID, the actual key. So name, user ID, which is a string or a number, name, API key. We need to generate this. Also need to return the actual API key here. We need to write a function that actually generates the API key. So static create random API key. I think there's a specific format these should follow. They all start with, something like this, sk or v1, which I'm sure they mean something, followed by random, string. So we should probably follow the same format. So return sk or v1 followed by, a random string, which will be, can be probably generated by something, a function, something like this. Let suffix key equal to empty string. When I say suffix key, because this is the suffix, this is the prefix. For let I equal to 0, I less than, whatever. API key length I plus plus. Suffix key plus equal to like a random number between whatever. A random string amongst these. I think you can have capital letters as well. Dot what is const alphabet set equal to this, and then it'll just be alphabet set of alphabet set math dot random into this thing floor. So this will basically return a random character amongst all of these. You add that 20 times. You have like a very long looking suffix which you add here. API key will simply be const API key equal to API key service dot create API key, which is a string create random API key. What else do we need here? Name API key user ID. As simple as this. Should probably be a number. That's it. Once you have that, you can simply return ID API key db.id and then API key, which is just the API key. Dot to string. Again, we're doing a lot of string to number conversions in API keys, which I don't like, but it's fine for now. I think that's good enough. If I go back here, await a create API key with this user ID and this body dot. How did you describe the types again? Describe the types like this. Body looks like this. API key model dot schema, and then response 200. API key model dot API key response success. No real reason for it to ever be a failure other than the fact that DB crashes. We should probably have another, status code here. I'm going to skip that for now. Body dot name, user ID and name, auth or API key service, which should have been exported from here. API key service dot create API key, async function. What's wrong here? Oh, I guess this is fine. Return ID API key. To do it, almost. All right, that should good. That should do it. Again, we'll test this very soon. The second one is going to be get your API keys. So again, on the service level, we'll describe a function called static async get API keys. This should ideally be paginated. We're not adding that yet. Const API key is equal to Prisma dot API keys dot find many, where user ID is this user ID. Convert it to a number, or just take this as a number here, and return API keys dot map API key ID API key dot ID followed by the name API key dot name, and then the other things, credits consumed key dot credits consumed, and then last used at API key dot last used. I don't know what's wrong here. Missed a comma here. That looks good enough. And then here I'm going to do const API key is equal to await API key service dot get API keys. User ID will simply come from here. And then should be as simple as return API keys like this, and then you should describe that the response should be a 200 status code with API key model dot get API keys response schema, which looks something like this. Name API key last use credits consumer should be credits consumed, should be a date. Last use should be a date. This should be a number ideally. Like this, and now the errors still don't go away. Why? Number, something is missing. API keys as an array of this thing should be a something like this, API keys, which is t dot array of t dot object of this thing. I think that should do it. Looks fine to me. So something is missing. Type problem is API keys followed by this thing. I was missing the whole word. API keys is this thing. API keys is name string API key string last use date issue number. Let's remove last use from here. Still a problem. T dot array T dot object of this thing. T of array of object of this thing. That looks fine to me. Let's just look at the type here. API keys is an array of this thing. String date number. String date number. credits consumed. Name API key last used credit consumed. Name API key credits consumed. Yeah, I don't know what's wrong here. Name. Definitely something's wrong in the schema here. Let's try to debug. I'm sure you guys can see it. I just can't. API keys. Oh, has an object array. So something like this. And what does this guy look like? So it should be something like this. API keys and 4 values. API keys and 4 values ka array. Name string, API key string, last used date, credit consumed number. Yeah, nothing feels wrong here to me. Okay, what if I do this? It does work. So what's wrong is the type that's being returned here. Oh, last usage date are null. So we should probably change that. Dot nullable. Date t dot nullable t dot date. Still didn't fix it. Now they should exactly be the same. I'm sure you guys saw it much earlier than me. ID, name, credit consumed, last used. Name, credit consumed, last used, API key. There's no ID here, which there should be, and there is no API key here. Now, it doesn't work. Now, the thing that was wrong was the ID is string, but I was mentioning it as a number. So let me quickly revert back here. And in our models, I should probably change this to a string, and that should do it. Oh boy, type safety is hard, but super important. Hopefully the error goes away now. That should be the get endpoint to get your API keys. The third one is going to be a disable endpoint. Hopefully this shouldn't be that hard because the return type is simple enough. Static async disable API key. This is where I would heavily use AI when you honestly user ID string, and then this actually might throw an error. So here we might have a body which will be API key model dot disable API key schema, and then response, which might be 200 if everything went wrong. API key model dot disable API key response schema, but there also might be a bad schema here. Failed schema, which should say disabling API key unsuccessful, which could be for many reasons. Where is it? Next.ts 411 API key model dot disable API key response failed schema. Here I would get the body as well as the user ID, and I would call auth or API key service dot disable API key with the user ID and the body dot ID. All right. Now we need to actually disable it. So wait, Prisma dot API key dot update, where ID is this API key ID. Set the disabled field to true. Should we allow enabled? I don't know, probably, right? what does OpenRouter let you do? It does let you disable. Does it let you re-enable? It does. So we need to do the same. Actually, let's do a bunch of things. Edit activity overview. We're not going to do all of that just yet, but along with disable, I'd probably do an enable, which would set disable to false. And again, you can expect a number here. You can expect a number here. All right. User ID. You should send the user ID as well to ensure only a user who has access to the API key can actually disable it or enable it. One thing I should do here is, what response do I get back? Like this. Will this throw an error though? Update one API key. Does it throw an error if it's not able to find one though? Now these are optional because Prisma does update through an error if not found. Also, it's very weird. It throws an exception instead of returning null. Yes, so it does throw an error, it seems. So what I would do here is, oh boy, yeah, I would just let it be like this. And then assume this will throw an error, which means in the disable, this place right here, I'd put everything inside a try catch. And if things go bad, as I will fix things, convert this to a number. Convert this to a number as well. Should there be a disable number? It should just be a put endpoint. ID, there should just be a put endpoint. I'm going to rename this to from disable to update, and same thing here. And the only thing we let the user update right now is the disabled field. We might change this later. Boolean, and I'm just going to call this a put to slash, and if, I mean, ideally there shouldn't be any logic here, but which basically means, you know, this would just be disabled Boolean, and that's what we'll forward here. And I would rename this to update API key disabled, something like this. Pass body dot disabled here, and if things go bad, then return status 411 and a message that says disabling API key. Disabling API key unsuccessful. If things go well, then simply return message that says, I would rename this, a bunch of things should change here. Update schema, updated API key successfully. And oh, my bad, here it should be updating key unsuccessful. There you go. Should do it. Yeah, now we have a generic put endpoint, but you can send a status that, a disabled field which could be enabled or disabled. That would let us not just enable API keys but also disable them. Delete should be simple enough. Again, body तो नहीं है, कुछ इसमें params है, which is id, which is a t dot string. Undefined. I have to figure out how you specify param types here, even though I think should just be able to infer it. Oh, yeah, there we go. That should do it. API key service dot delete the ID of the API key, as simple as that. Go back here, add another function called delete. It will take the ID, which will be a number, and then the user ID, which will again be a number. Both converted to numbers. There we go. Where did I add this? Oh, static async await Prisma dot API key dot delete, where ID is this ID and user ID is this user ID. That should do it. And to response 200 status code should return again auth model dot delete. Sorry, API key model dot delete API key response schema. And there should probably be another one again. I would assume delete also throws. Let's see, what does it return? It returns this. So I would assume it just throws if it can't find the specific thing to delete. Also, I think you guys got it before I did. You don't actually delete it. You actually just update where ID is user ID is this, and you set deleted to true. You don't actually delete it because there are foreign key constraints that'll get violated if we actually delete the thing. So you just update with disable set to true, and also when the user gets their API keys, we should only return them the API keys where deleted is false, not their deleted API keys. Beautiful. This thing, and then return API key deleted successfully, something like this. But again, it can happen that there was no API key for that specific ID, or that specific user did not have access to it. Hence, we're also going to put this inside a try catch. And if there's an error, we're going to also add failed. Deletion failed, something like this, and import it here under 411. Return message this. There we go. Oh, my bad. Return status 411 followed by this, where status comes from here. I think that should do it. I think we have the 4 endpoints ready now. Let's see, create an API key, get an API key, put an API key, delete an API key. Let's test it out. Let's take this app and import it at index.ts in our primary backend. Import app as API key app from API keys, copy, and then .use, .listen. There we go. That should do it. Everything looks fine. Let's restart the application. Requestly. Let me copy the cookie now. Let me sign in again. Does it work? Is it still connecting to the same database? Are we good to go? Yes. Now let me copy this cookie. Let me send a request to /API key. API dash keys, API dash keys. a post request here with a cookie. So I think we can do it in the authorization as well. No, here itself, cookie, paste this, and a name for our API key, which, I can just name it my Mac machine, or, that's a dev environment, something like this. Send and a 500 status code because query failed. With no good reason, it seems. I don't know why all the errors are a little silent. The good thing is we can always try catch our way through it. Either things are failing here or they're failing here. I would assume they're failing here. Let me put a log here, hi there, and see, does it actually hit this endpoint? Indeed it does. What happens after it hits it? It calls this thing right here. Let's look at what happens here. Most probably this is failing. So let me just quickly put this inside a try catch and figure out what's up. I also need to figure out why are all the errors silent in Elysia. I'm sure there's a way to start it, with the errors actually populating in the logs. All right, let's try that one more time. This time is the error. Argument user is missing. Did I not give it the user ID? I did. Is that not enough? It should be. Schema.prisma. User ID name API key. This defaults. This is optional. This is a relationship. User references ID of the users table. Yeah, that should be fine. Unless, as you can tell, the user ID is not a number, and name is 5. What does it expect? Name and user ID. What am I passing here? User ID and name, which I've converted to a number. Name and user ID converted to a number. There we go. That should probably do it. Yeah, let's try that one more time. Send. And this time it returns, wait for it, a body that says ID2 API key, this thing. It does return me an API key. It looks smaller than I would expect it to be. I think I selected the length as 20. I don't know why it looks smaller. We'll see what's up there. But other than that, I think we're good to go. We've been able to create an API key. Let me create another one for the prod environment. Another one for the staging environment, maybe. And after that is done, let me try to get all of my API keys. I'm able to get 4 of my API keys, which is beautiful. Let me try to update an API key. So that's going to be a put to an API key with an ID of, let's say, 1. And I want disabled to be set. Oh, hold on. When I get all the API keys, I only get their IDs for some reason. Did I miss something? If I get all of my API keys, I only get their IDs, even though I should probably get more than that. Let's see what's up here. Oh, my bad. I think I did a bunch of command C here and got rid of the other things that we needed. It's all good though. I can always add them back. These are the 4 things that we need: the ID and the API key, which is going to be a t.string, and the name, which is going to be a t.string, and credit consumed is going to be t.number. And lastly, this is going to be t.nullable, t.date. My bad on that. Let's restart. Let's go back here. And now I should hopefully see a lot of them with all the data in there. That looks good to me. If I try to update the one with ID1 and set disabled to true, should probably also return if it's disabled or not. So disabled t.boolean. over here, I would also return disabled key dot disabled. All right. Now, if I try to send that request again to put, which means update this API key, it tells me ID was to be string but found undefined, even though I did pass it. JSON, let's try that. There we go, updated API key successfully. If that is true, then if I get all my API keys, the first one should ideally be disabled, and it indeed is not disabled. Oh, but the last one is, oh, ID1 is here, ID2 is here. My bad, it does get disabled correctly, so that's the third endpoint. Post seems to work, get seems to work, put seems to work, delete is the only one that's left, which should be simple enough. Let me delete API key 1, API key 2. Let me try to delete API key 100, and it says failed, which is good. But if I delete 1, did it successfully, and if I try to get, I should not see API key with ID 1 and 2. Let's see if that is true. Indeed, I only see 3 and 4. Beautiful. We were able to complete the API key endpoints now. I think this is all the endpoints that we need. One, I'll start from the top. A middleware that does all the authentication, an endpoint to create an API key to get all my API keys, to mark it as disabled or enabled, and to actually delete it. These are the 4 things we need in the API key endpoints. Next up, we need to do models and payments. We'll do models first. Should be simple enough. The thing is, we don't need to expose any of the post endpoints here. The end user should not be able to interact with our backend to create models. That'll all be done by admins of the website, probably through an admin dashboard or directly in the database. So it's pretty much going to be a bunch of get endpoints. There'll be no put endpoints, no post endpoints to change anything in the models. They don't necessarily need to be authenticated either. They can be public endpoints to get what all models we support right now, their history descriptions, so on and so forth. So I'm probably just going to vibe code this one. Hopefully it's like pretty easy to code yourself as well. A bunch of get endpoints that lets the user see the models that we support, the providers that we support, and what models are on what providers. That's what this is going to be. Payments is going to be a little tricky depending on if you're using Razorpay or not. For now, I'll just expose a dummy endpoint to on-ramp on the platform. That means a dummy endpoint you can hit to give yourself free 100 credits or 1000 credits, and we can go from there. Or what we can do is, for now, we can just default the user to 1000 credits or something like that, so that when they come to the platform, they can actually use it without increasing the credit value. We'll decide which one of these to do. With that, moving on to the next section, a little bit of vibe coding, actually finishing the models and the payments. I think both of these can be vibe coded. Payments being a dummy of an on-ramp endpoint right now that lets you on-ramp credits, that means increase credits, and models lets you expose the models, the providers, and the relationship between them, what models can run on what providers. Let's get into that. Next, I'm probably going to use Claude Code for this. You should type it yourself. Alrighty, we finished the rest of the backend routes in API backend, at least the ones I can think of right now. I'm sure there are some I'm missing. The ones that I can think of right now include models that includes the providers that we have, the models that we support, and what models are on what providers, and payments. That again is just a simple endpoint that lets users on ramp for now. So we'll just show a button on the UI that says on ramp 1,000 rupees or 1,000 credits, and the user will just on ramp immediately. Eventually, we'll add Razorpay Stripe if need be. As I said, I'm going to wipe code this one. So let me open Claude Code here and ask it to finish the models and payments routes based on the structure of the auth and the API keys routes in apps/primary backend. The models APIs are supposed to only expose the models, the providers, what providers are linked to what models. No post endpoints should be exposed. They will be added by the admins directly in the database. For on ramp, simply uh, add one endpoint that users can hit for now to on ramp 1000 credits. Eventually, we'll add razor pay, but not right now. I hope that should do it. I think that explains the statement fairly well. And let's see how long it takes. It's 3:53 right now. Let's see how long it takes for it to finish the whole thing. I have to see it. It slowly started to create these files for me. Right, seems like it's done. It's 3:55 right now. That means it took it 2 minutes. Let's see how well it did. Let's start with the simpler ones. Payments does use a GWT, which is good. Does have the middleware, which is good. Does have an on-ramp endpoint that simply calls the on-ramp function. If something goes wrong, returns an on-ramp failed. Let's look over here. That looks good to me. That looks good to me. Ideally, these should be in a transaction. So that's one thing I'm going to change. Are you sure the on-ramp transaction DB calls shouldn't be in a DB transaction? Because it might happen that this succeeds and this fails, and we don't want that. And I think it should be easy enough for it to fix. Did it fix it though? Oh yeah, it did. So now it's a transaction, which is what we'd expect. Cool. Nothing looks wrong here. Models.ts looks fine. Now let's go with the more complicated one, which is models. Get all the providers. Get the providers for a specific model, I would assume, and get all the models. That looks good. The first one would return you all the models that we have with their company name and website. That's fine. The second one will return you all the providers for like a providers page. Might actually be a fairly vigorous endpoint. And lastly, for a specific model, all the providers that we have, which seems like this is fine. Yeah, I don't mind this. Cool. Yeah, I don't think anything's wrong here. One thing we should do is test. But to be able to test, I actually need to put some models in the database. I think I'm done with all the Claude coding for now. Let me open a visualizer for my database. So that's bun, oh sorry, cd packages slash db, bunx prisma studio. Should probably open a UI in which I can, populate a few models. and providers. I would probably kick things off with companies. Let me add company number 1. That's OpenAI, and their website is chat.com. Save. Let me add another one. That's Anthropic, and their website is claude.ai. Let me add another one. That's Google. Their website is well, I don't know if google.com is the right one. I would probably put something like gemini.com here, or gemini.google.com. Yeah. Save. All right, we have all three of the like major companies here. You can add like the Chinese companies. I think I just picked the bigger ones right now. Models, I would like to add the very first one for the company ID. One was OpenAI, right? Yeah, I would add GPT 3.0. And I would like to keep it slug as OpenAI / whatever OpenRouter has, honestly. So I would just go here to the models and search for GPT-3. There's GPT-3 Turbo. There's like a lot of them. So let's just pick this one right now. GPT 3.5 Turbo. This looks like a good title for it. And then a slug I'll just copy from here. That should be the first one. I'll pick a bunch of other providers. A bunch of other OpenAI models. GPT 4.0. Same company ID. Slightly longer name. And a weird slug. Save. That's 2. Let me add another one. There's like a lot of OpenAI models, huh? I guess these two are good enough. Search for OpenAI. I'm pretty sure that GPT-5 should be here. Yeah, GPT-5 Nano. Let me copy that. Insert row 1. This one. Save. Alrighty, good to go. That's 3 models that we've added for one company. Let me also do another popular company. This one's going to be Google, which I think had the ID of 3. And for Google, what do we have here? We have, I think this might be a free one. Google / Gemini 3 flash preview is the slug, and the name is Google Gemini 3 flash preview. Save. What else do we have here? I mean, there's like a lot of them, but I would try to get a few. So let's do 2.5 Pro. And then I'll just go with the third one, which was Anthropic, where we have Claude Opus 4.6. And 3.7 Sonnet. Save. Alrighty. I think that's good enough. We support 7 models for now. We have 3 companies high level whose models we support. And model provider mapping is going to be tricky because I probably need to add a bunch of providers first. Yeah, this is where things get tricky. The provider schema should probably be a little more complicated than this. There should be some API key or something here. But let's start off with this. Google AI might be one provider. Or Google API, I guess, is a better name for it. Website would probably be Google API Gemini. Probably this one, aistudio.google.com. this seems to be the harder part now, seeding the data. The provider might be, Claude API. Website would simply be claude.ai. And then another provider might be OpenAI directly, probably api.chat.com or chat.com, either is fine. Save. We have 3 providers right now. I would like to add a 4th one, something like DeepGram or Google Vertex or Amazon Bedrock. I said Redbox. So that we can also have a 4th provider that that supports multiple models and not just one. Let's start off with 3. And model provider mapping might be the last one, for which we'll have to. I don't remember the IDs exactly, but model ID and provider ID is what we need for now. All right, let me open this in another tab. So model ID, there's a lot of them. Model ID 1, 2, and 3 are all on OpenAI. So model ID 1, model ID 2, model ID 3 are all on provider, the OpenAI provider, which is the 3rd one. So 3, 3, 3. I can let the costs be 0 for now, eventually change them. That's good enough. Another set of rows for the second set of providers that are by Google. So these 2, 4 and 5 will have the provider as Google. So that's 1, 4, 5 and 1. Looks good to me. And then the 3rd one would be the rest of the models. That's 6 and 7. And the provider ID here is going to be 3. I think so. Or is it? These are Anthropic models. So this will be 2. Beautiful. I think I've seeded enough data. Yeah, that should be good enough. To actually show something on the front end. Might be good to add logos, even though I don't see any logos here on these guys' websites. So I think we should be fine. Cool. Let's begin by testing these endpoints now. If I go to apps/primary backend again, bunch source/index.ts, open requestly here. Let's see what we can do. Localhost colon 3000 slash. Let's start by testing the model. So if I go here, /models/, that's it, I guess, get. Let me get all the models. And what do I see? I see model number 1. That looks good to me. Model number 2, model number 3, model number 4, 5, 6, 7. We support 7 models. That's good enough. I don't think we need the providers here just yet. The second one was providers. So what all providers do we have? /models/providers. And this time we get back 3. Because we only support 3 providers right now. Eventually we'll probably need more. And then the third one was all the providers for a specific model. So for the first model, the providers are, first model was OpenAI, I think. So the provider is OpenAI. Second one, something else, so on and so forth. The thing is, I probably want to add another one that supports everything. So that's going to be Studio again. And CD packages DB, Studio. Just to make it a little more full, I would like to add another provider that supports everything. So I think Google Vertex supports all models. If I'm not wrong, we can actually maybe not. I think it supports. We can confirm from OpenRouter. Does it? Is this? No, OpenAI is the only provider for GPT 3.5 Turbo. Let's look at Anthropic. Look at a random one. What providers does this guy support? Anthropic, Amazon Bedrock, Google Vertex. So Google Vertex would support Anthropic and, of course, Gemini. I would just like to confirm that somewhere here. I would assume it's not as easy to get Google Vertex API keys. I could totally be wrong. Yeah, seems like it does. It'd just be a little hard to hook it up. But I'm going to add it to the database irrespective. So if I open the database now, I would add another provider, Google Vertex. And whatever their website might be, probably cloud.google.com, I'd say. Save, and this new provider that we have 4 supports all the all the Claude and the Google model. So that's everything from ID 4 to ID 7. 4, 5, 6, 7. 4, 5, 6, 7 are all supported by provider ID 4. That's Google Vertex. That's good enough. We need to update the input output token costs. Where we have to do a bunch of math around, how much money do you put in to earn Y number of credits, and how much, if does $1 per million tokens translate to in our credit system. We'll come to that when we come to that. I'm going to leave these as 0 for now. Now, if I send the same request and request, hopefully I see 2 providers, unless this was OpenAI, where there was just 1. Model, oh yeah, this was OpenAI, I think. Yeah. But if I look at 6, something seems wrong here. Models /6 /providers only has OpenAI as a provider. 7 only has OpenAI as a provider. 3 only has OpenAI as a provider. That looks wrong to me. That means our vibe coding did not vibe very well. /colon ID /providers. Web model ID is this. What did I do wrong? Model ID 3. This one right here only has provider ID 3, it seems. Model ID 7 is in 2 places. Let me try 7. Still returns this. So something is wrong for sure. I doubt restarting the backend changes anything. Hold on. How is the backend even running right now? One source / it might be a cached response, most probably. cd primary backend bun source / index.ts. Now it is running. Now if I send the request, I should hopefully see, wait for it, 1, 2 providers. If I send it for model ID 1, I should see 1 provider. If I send it for model ID 5, I should see 2 providers again, because this specific model is supported by whatever, Google, as well as Google Vertex, as well as whatever, Google AI or Google APIs. Cool. That should finish the primary backend. I'm sure I'm missing some endpoints. Might be a decent time to write the front end as well. I mean, we can basically decide how to proceed from here. We can either write the API backend first or the dashboard frontend first, because we've done everything for the dashboard frontend. There's nothing really left to be able to build a dashboard for the user, where the user can see the providers, create an API key for them, on ramp some money, see some credits, so on and so forth. So we can actually build the front end first, and maybe then eventually move on to the primary backend, sorry, the API backend that the user will actually hit for forwarding model requests. So let's do that next. Let's probably just write code the front end as well. I think we've written very clean, whatever APIs. I think AI is good enough at writing front ends. And if I write it from scratch, it'll probably take, even though there is one thing I really want to learn. So maybe we'll create one component because I really want to see how ElysiaJS provides end-to-end type safety. And how you can use the end-to-end type safety to your advantage. Is there some query library that they prefer you to use, like React queries, so on and so forth? Just for that curiosity, I'll probably build some part of the front end, and then we can just wipe code the rest. Let's go move on to that next. Let's build at least one component of the front end ourselves, and then we'll probably wipe code the rest. I'll see you in that section. Right, we get into the interesting bits. We get into the front end next. One thing you should know about Elysia, which I learned 2 minutes ago, is Elysia provides end-to-end type safety using a sister framework of theirs called Eden. This one right here. Oh boy, their explanation is long, but long story short, it provides you end-to-end type safety similar to TRPC. I don't know if you've used TRPC, but basically it'll make hitting the backend very easy. And on the front end, we'll get the types for every API request that we're sending, which is very cool. We'll kick things off with the installation. Before installing, I probably should do one thing. The way Eden works is whenever you've written a backend, you need to export a type, specifically the type of this app that you're going to import in the front end. And this type is what gives you end-to-end type safety, is what gives you a bunch of functions that you can call to hit the backend. And hence, my primary backend now needs to export something that I need to import in my dashboard front end, which is always tricky. Ideally, an app shouldn't be exporting something that's imported here, but I'm just going to roll with it. What I'm going to do is create a new file called app.ts, move all the logic here, and export two things from here. Export the app and export type app equal to type of app. In index.ts, I'm going to import app from /app, and then actually run app.listen 3000. In here, I've exported this type that I'm now going to import in my front end. To be able to do that, I need to export this file from here. So export under /source/index.ts, I think. Oh, sorry, app.ts. Or maybe /app is a better sub prefix for it. In the dashboard front end, is this a Next.js application? No, it's a simple button front end. Beautiful. What I'm going to do is I'm going to go to package.json here and add app as a dependency. Sorry, primary backend as a dependency. Oh no, it is named app. Primary backend is named app for some reason. Because I initialized it using Elysia. I guess that's fine, even though it should ideally say primary backend. And in my probably index.tsx or app.tsx, I'm going to get rid of all the default React code that I have. And I'm going to try to import app from app after I do, or app slash, how did I export it? Well, I exported as app/app. Hold on, package.json. I'll probably just export it here at the root level, and I'll import it here from app. The one thing I should do is do a global one install, and I think that should do it. Yeah, that looks fine. Import type app from app. Beautiful. That does exactly what we needed. The next thing we need is a bunch of routing here. But before we do that, let me quickly try to hit the backend and see if things do work as expected. So what I'm going to do now is what these guys have done here. Const client equal to treaty, which comes from one add, I would assume ElysiaJS Eden. Let's see what the installation steps are. Hold on. ElysiaJS / Eden, and also Elysia as a dev dependency. Now I can probably import treaty. And now let me try something. Let me try hitting the backend using, I don't know, client dot, there we go, auth dot sign in with, I'm assuming, a username and a password, email and password. Email, password. Oh, dot post. String is not assignable to, oh, okay. Email and password. Ideally inside, a use effect, but yeah, let me just do that. What's the type of result here? The type of result is, oh boy, a lot of things. If result dot status equal to 200, then I probably want to see result dot data, which will probably have the right type. Message string. Beautiful. So this, I hope you guys understood what I did here. If a user ever wants to sign up, they'll probably see, two input boxes, one for email, one for password, and then a button that says whatever, sign in this case. If I run this front end and go to localhost colon 3000, oh, I see a lot of things. Let me get rid of the CSS files. Let me restart the front end. I see an email, password, and a sign in button. And what I can do is when the user clicks on the sign in button, on click equal to sign in, I can actually send a request to the backend without any, library like fetch, with extreme type safety, because whatever, data I'm getting back, I can actually check if things are good or not. And whatever, alert the user, log in the user, so on and so forth. So now, the only thing I want to try next is, if I do give it a random email and password and go to the network tab, click on sign in, I do get back a 405, which says method not allowed, which is weird because I'm running the front end on 3000. Let me change that. Let me go to frontend / package.json. And when you do dev, I probably can do Redis port 3001. There we go. No, didn't do it. Bun -- hot dash port 3001. Yeah, that should do it. And let me also start the backend here by running bun dev. Now, if I give an email and password, click on sign in, look at that, a request goes and it returns me a 403 because this is incorrect credentials. But if I open my requestly and try to find the credentials from yesterday, that indeed did work. Probably go to the history somewhere here. There we go. We know for a fact that, oh, I can't find that specific endpoint that I was looking for. But either way, I'm pretty sure this will work. It returns a 403 for incorrect credentials. If I remember, I don't remember the right credentials, but if I do put in the right credentials, which probably was something like this. Oh, wow. First guess? That's crazy. Or was it? It is pending. Hold on. 403 again. Yeah, I don't remember, any of the right whatever credentials, but I can always, create a sign up page, so on and so forth. So this is how I'm going to connect to the backend by using the Eden library or ElysiaJS / Eden library rather than, writing HTTP endpoints or sending fetch requests. The other thing we need to do that I'm going to do is use React query for, fetching the data invalidating cache or caching the data, sending requests in the background, so on and so forth. So there are two libraries that I'm going to use to make this fancy. Other than that, it should be fairly simple. I probably need to add routing as well. So let me do that as the first thing. Let me just comment this out because I'll probably give it to the AI eventually to use this as the benchmark to create the front end. But before that, I need to add add React router DOM. I think React router DOM. Let's see. I've always hated their UI. Docs, installation. Is there no easy way to do it? I'm assuming it's simply one add React router DOM. I could be wrong. Or maybe React router, I don't know. I've also added it in the wrong place. I added it in the backend when I was supposed to add it in the front end. So let me get rid of these from the backend. And let me add React router DOM as a dependency in the front end. Again, I'm forgetting if it's React router or React router DOM. I think React router might just be it. If I go back to app.tsx, I can get rid of these. I can always recreate them. Import browser router from React router, add browser router here. And what is our app going to be? Routing. Man, they never make it easy, do they? It's been years since I've been going through these docs. It's always not very easy. They basically show you two ways of implementing routes. I'll just pick and choose. I think it looks something like this. Routes followed by route path. Oh, sorry. Route. Yeah. Route path equal to slash sign up component, or I don't know. Path, and then what's the other thing? I think it's component if I'm not wrong. Actually, I might be wrong, most probably. Let me create a new folder here called, let me actually get rid of a few things that we don't need. And now let me create, oh, this looks like we already have shared CN here, which is good. A folder called pages, where I'm going to render all the top level pages. There's going to be a signup.tsx. There's going to be a signin.tsx. There's going to be a dashboard.tsx. There's going to be a credits.tsx probably. And then there's going to be a API keys.tsx. I think that should do it. We probably should have usage eventually, to show you your metrics of how you're using the app. But we'll get there when we get there. Let's start off by exporting a function sign up in this case, which simply returns, whatever, sign up for now, sign in here, dashboard here, credits here, and lastly, API keys here. This is again one place I would strongly use AI to speed up this process. Again, this looks incorrect because it's supposed to be something else. Again, I'm missing what it is. I always have to find it. Oh, there you go, element. Beautiful. Sign up, and similarly sign in, and then dashboard, and then credits, and lastly API keys. Beautiful. Let's see, does it work? If I do a bun dev and go to localhost 3001, I see a error which looks unrelated. /sign up shows me this. We also probably need a landing page. So let me also do this. Cool. That should do it. If I go back here, I can see a landing page, so on and so forth. I've set up the routing. I'm going to implement one such page really quickly, the sign up page. So the AI has reference of how to hit the backend. And then I'll ask it to finish the rest of the things. So the sign up page should have a button for, again, the same thing we did before. Sign up, and then an input box, placeholder equal to text, email, type equal to text, and then one for password. Const email ref equal to use ref, const password ref equal to use ref, email ref. That's how you do it, right? HTML input. Probably don't need these. And when the user clicks on the button, that means they want to sign up. This function gets called, which will actually hit the backend through a React query mutation. So let me also add React query as a dependency. I think when you do that, what you need to do is add a top level context here. Import query client from React query. Let's just go through the React query docs. After you add React query as a, dependency, which I just did, and it was indeed incorrect what I added as a dependency. Dashboard frontend React query, get rid of it. Stack / React query. The next thing you do is you create a new query client in app.tsx, and you pass that to a query client provider to the rest of the components. / this thing, beautiful, import this from the right place. And now in signup.tsx, what I need to do is create a mutation, which you create like this. Const mutation equal to use mutation. The function to call is going to be, now this is where the other library comes to the picture, which is import. I probably should have a provider for that as well. Let me create another folder here called providers, inside which I add eden.tsx probably. There's probably a better name for this, where I just export this object and pass not just this object, but also a context that wraps it. This should probably be process.env.wait or this isn't wait actually, dot backend _ URL or this thing. This will come from app, and then export const eden context or eden context equal to, oh boy, it's been a while since I've written React context, isn't it? React context. There we go. React.dev, best resource for learning this. Let's go back here. Oh boy, I get it. Create context, beautiful. Create context with this client. And then ideally you should export its providers separately. export const eden context, or actually I would just call it Elysia client context, and this Elysia client context provider equal to Elysia context dot provider. And then the other thing I need to export is a hook, which is, use Elysia context equal to uh, use context of this thing. I think that might be right. Now I don't need to export this. I'll take the provider and put it in at the top of app.tsx as another provider that will provide, in this case, might have to do this here. Again, it's been a while since I've done this, but I'm sure I can figure it out. But why do I need to provide one here then? If I'm just going to redo it in there, let's see. Provider. Yeah, this seems weird. Do you think, I mean, how have I done this 1,000 times yet? I'm confused here. When you create the context, you do give it a value and then you update the value, is it? The section this level. There also is the value of nearest above. Feels weird that I have to redefine it, something like this, but I will take it. And I will go back to the sign up endpoint here and do a const Elysia client equal to use Elysia. Did I write context? It should be use Elysia client. And now what's the type of this? It says any, which is not great. Yeah, I'm sure there's a better way to do this, but I'm going to go with this for now. Export. Oh yeah, it's probably this. Export const use Elysia client equal to const client equal to use context Elysia client context return client. No, I don't need to export this, and now I'll simply say use Elysia client. Now the type indeed is correct, and our mutation function is going to be Elysia client dot auth dot sign up dot post with user email ref dot current and password ref dot current. Yeah, on success invalidate queries for honestly nothing. That could be empty. Mutation. React query. use mutation or just the quick start mutation. How do you call it? On click equal to mutation dot mutate with the right inputs. So on click equal to mutation dot mutate with ideally the email and password from here and a bunch of other checks. So ideally I'll just take the email and password here and pass them directly here. All right, I do see an error here though. We'll figure out what that is. This one would be email ref dot current and password ref dot current. The parameter password and context are incorrect. Okay, is it going to be this then? Seems like it can only take one argument. Email probably can take more than one. I'm just missing something obvious here, but I'll just roll with it for now. Ideally, I should add some checks here. If the user doesn't have, an email or password, I should just, throw an alert, or just disable the button, whatever. There's like a lot of things you can do here to make the UI pretty and a little more strict. Right now, if I don't put anything in the email field, it still sends the request, which is not great, but nothing we need to worry about right now. That's how we create the mutation, 2 input boxes and a button. Let's see, does the sign up page work or not? Let me do a bun dev. Let me make sure the backend is running. So let me go to localhost colon 3001. Let me go to the sign up page. There's probably a better way to get environment variables here that I'm going to figure out eventually. For now, I'm going to get rid of this. Refresh. No query client set. Query provider set 1. Only thing I can think of is this, which probably shouldn't be the error. No query client set. Use query client provider to set 1. Think I did that right here, didn't I? Go back to the sign up page and that seemed like the first tricky error for the day. No query client set, even though, oh, no, that's fine. Query client equal to new query client, and then client equal to this thing. Yeah, let's see right here. I am importing from at tanstack / React query here, but from React query here. I should import from the same place. That should probably fix the error, and indeed it does. Thank you, Stack Overflow. After many years, I come to you. Right click, refresh. Let's look at if I give it an email and password, do I get back any response? I don't. Even if I click on sign up, nothing happens. Why would that be? I am on the sign up page. Ideally, this should call .mutate, which should call this. Why is there an error here? Expected a comma. Oh, my bad. All right, let's do a console.log hi here. Refresh, sign up again. And I do see highs again and again. I don't see a request go to the backend. Why would that be? Dot post email dot. Let's put an email. Let's put a password. Sign up. I still don't see a request. I'm just not using React query correctly. I do see a hi. What if I put this outside? Now do I see a request to sign up? I do. But if I remove this, if I click on sign up, even though I see a log that says hi, that means control reaches here. This line of code does nothing. Why would that be? Email console.log password. My guess is the email and password are incorrect. Yeah, my bad. Dot current dot value. How does it not know? All right, that should do it. Sign up, and there's a request that goes. Beautiful. Sign up, we see a sign up request. We see a course error, which is something I wasn't really hoping for. Because I didn't see it before. How did course suddenly pop up out of thin air? Oh, not really. Anyways, should be simple enough to fix. Let's go to index.ts in the primary backend. And I would do app.course, ElysiaJS course dot use course with probably some things that we should add here, but I'm not going to for now. Let me restart the backend. One add Elysia/course as a dependency. One dev. Let me go back here, and now I probably shouldn't see any course errors. Beautiful. The request goes out, and I get back a 200 for signing up. What if I sign up again with the same email? I get a 400 bad request with a response that says error while signing up. A few things should change. This should really be an email. So we should probably add some sort of dependency on the backend, or sorry, some sort of check on the backend to ensure the user is only sending an email. But that's fine. Signup.tsx is done. I have React query. I have Elysia client. I have end-to-end type safety. I have an ugly looking sign up page. We now need to finish everything that's mentioned in app.tsx. That's the landing page, the sign up page, the sign in page, dashboard credits, and API keys. This is going to be a long process. If I write it myself, it should probably take me 2 hours, if I'm using no AI, to finish the whole thing with an ugly looking front end. Probably 10 hours with a tasteful front end that, I'm writing and designing myself. I'm not going to do that. I have written the basic structure. I hope AI understands what I expect from it. When it comes to the libraries to use to fetch the data from the backend, and the libraries to use to do, querying and caching, things like these. I think it's smart enough to know how React query works. I would hope it creates my components the right way. So what I'm going to do now is go component by component or page by page and finish all the pages and see, does it work as expected or not? Is it able to create a website where I can sign up, sign in, see my credits, see my API usage, see a button where I can click to increase my credits, let me create an API key, delete an API key, disable an API key, so on and so forth. So welcome, good old friend. Welcome back. What I'm going to ask you to do now is complete the front end. I have created the structure of the sign up page to show you what libraries to use throughout. Please finish the rest of the front end that includes the all the pages mentioned in app.tsx. Let's go page by page and get things reviewed from me. Also use the front front end design skill. Also use the front end design skill to make a fancy looking UI. Enter. All right, let's see what it does. You will notice in this journey of building this application, we've spent a decent chunk of time structuring the backend and now structuring the front end, which will probably have incremental effects as the project grows, which is usually a good thing to do rather than one-shotting a project like this. Even though I think this is a simple enough project to be one-shotted by an AI like Claude Code, but I would still structure things and then sort of ask the AI to finish the rest for me. While it is exploring my repo and building my first page, there's not much to do. I'll probably go sip some Coke and see you guys after it finishes the first page and asks me for a review. All right. It seems to have finished the first endpoint, which was, sorry, the first page, which is the sign up page. I'd created a version of it. It made it slightly, well, it did inundate my code correctly, which is great. And other than that, just made things prettier. I don't see any usage of shadcn here, which isn't great, and something I would have liked, but I would like to override signup.tsx and then test it out here. If I go to 3001 slash sign up, and if in another tab here, I rerun the front end, I see a very weird looking sign up page. Most probably because Tailwind isn't working correctly. That'd be my guess. And that broke because I probably, yeah, there you go. I got rid of this. So let me just get rid of the rest of the CSS, but still have the Tailwind CSS in there. And now that looks decent enough. Sign up page with some glowy thing here, which I don't hate. Let's see what happens if I try to sign up with, pretty random credentials here. The first time it gets stuck, or there is no any logic yet to redirect it to the sign-in page. 400. Okay, that's probably because this email is already used. But if I do it with an email that isn't used, I do get back at 200, but there's no, implication here that I've signed up. I'm hoping Claude Code is just working right now. After sign up, I should see some feedback on good or bad things. Right now, nothing happens, just the button becomes usable again. Let's see what they've done. Signup.tsx, mutation.mutate. If it is pending, show a loader, let's show this thing. Yeah, it doesn't do much with the result, does it? Although it does do a few things here. If it is error, then show the error. But I never saw this error though. Seems like my context got compacted. A few things are happening here, which all look pretty bad. I think my context got compacted here, so it's reading through the files again. Meanwhile, Yeah, I could have sworn we see this here, but seems like mutation never gives an error. Um, let's see if we can fix it on its own. Never mind, I'll do it in a bit. All right, that looks better. It throws an error if it actually returns an error from the backend. A bunch of other things. It says redirecting you to sign in. I don't know if it does. And try the third thing here. Let's try it one more time. If I do it with an account that already exists, it returns an object, which is beautiful. Is what I see as the error. But if I do it with one which doesn't exist, hopefully it does work. Account created, redirected you to sign in, and it does redirect me to sign in. So anything that's left is fixing the error. I don't know if we can change something here. Let's see what it does. Response.error.message. Now the one thing it should know is there was type safety here, and actually I should have just told it that if response.status equal to 200, then return response.data. Else, again, it should just check if response.status equal to what else can it be? Can be a 200 or 400 or 422. 400, then value. Let's see. Dot message. Okay, now comes the conflicts. Yeah, I would not use those, but since it's already written it, I'm going to go to signup.tsx and fix it again. Error.value. Okay, seems like I was able to figure out the types and do what I was hoping for it to do. Let's try it again with something bad here. Basically an email that already exists, and now it says error while signing up. But if I try it with an email that doesn't exist, my bad, it does redirect me to the sign in page. I think that's good enough. We can iterate on it. Let's move on to the rest of the pages, do them in one shot. I'm hoping it does understand everything now and I don't have to go fixing its problems. But yeah, zero effort and looks pretty decent. I would probably name it something other than OpenRouter. But other than that, man, it's getting good at UI. And there was a plugin that it asked me to create or add. Why does it read these files again and again? It just seems like it's increasing the money that I'm spending sending tokens. I'm pretty sure it read all of these files before. Anyways, we'll wait for it to finish and see what it creates. And then if there's something to fix, we'll fix that later. See you in a few more minutes. All right. Seems like we have a functioning front end. Let me show you what it looks like. There is a landing page. Right after you go to the landing page, there's a sign up and a sign in page. I can sign in as a new user, let's say Harkirat or h2@gmail.com with some credentials. I can sign in using the same account. And once I do, I can do a bunch of things like creating my API keys, exploring the model providers, so on and so forth. If I go to the API keys section, I don't see any yet. I see some inconsistency here that I should fix. Let me create a new API key called dev. and created it. I can copy it only once. Let me keep it handy. And if I refresh, I still see it here. Again, the name looks a little weird. We can fix that. The second thing is I can hopefully add credits. If I click here, hopefully my current balance is 1,000 now. If I add another 1,000, I have 2,000 credits in my account now. I've used 0 credit, or do I? Doesn't show me the available credits, which it should. Current balance. It only shows it to me in certain cases, although use per key breakdown. I'll probably add a third card here, which just shows me my credits. Or I can just add, current balance, these many credits. Do we expose a function that has my credits? Probably. Auth. We probably don't actually. Yeah, we don't expose anything on the backend that shows me my credits. We probably should. So I'd add a third endpoint here called .get/credits. That'll just return me my credits. It will be an authenticated endpoint, which is why I probably don't want it to be here. But it actually belongs nowhere. We'll have to add a new module here to expose the user's credits. They should be shown, somewhere in the top bar here, how much credits you have left. And right now, it only shows us the credits you have used, which is not great. One thing to add. The other thing is the fonts are incorrect. Sorry, the colors are incorrect in a few places. We need to fix that. The credits page should show the credits. Very easy doable ourselves as well. So let's just try to do it ourselves. Yeah, I guess it's fine. Was it a handle? The same one as we have here. Oh, sorry, a resolve. And I hope it only applies to all the endpoints that come after. .get /profile. It should return me a bunch of things about my profile. For now, I'll simply return, probably don't need all of this. For now, I will only return the credits the user has in their account. So in the auth service, I'll expose another function called static async get user details. For a specific user ID, return prisma.user.find first, where ID is this user ID. It should be a number, and what I'll pass here is also going to be user ID. Auth service dot get user details user ID. Const user data equal to this thing as a number. And then one thing I need to ensure is I only select the credits here. We don't want to return anything else to the user yet. Return user data. I probably should add the responses here. This looks wrong. Response, yeah. Response is going to be 200 with some schema that I'll again have to define here. Export const, this would be called profile schema or profile response schema equal to t.object credits t.number, I would assume. And let me add that here. auth model dot this thing. And we see an error because schema.prisma credits is actually an integer only. What's the problem here? This works. This doesn't. Can you guess why? Because I need to await it. Still doesn't work. Credits number or null. Yeah, if not user data, we should also probably return status of 400 with a message that says, error while fetching user details. And this should be status. And this should be 400 comma. Error schema, which has a message that says error while fetching users details. I think we're good to go. We now have a profile endpoint as well. Which we can use on the front end here. Probably here itself. Const credit user profile query equal to use query. Query key is going to be user profile, and then query function is going to be async const response equal to await Elysia client of auth dot profile dot get, and then if response dot error, just throw a new error while fetching user details, else simply return response.data, which hopefully has a nice type. It does. This is the query, and this query dot data const credits equal to dot data dot credits is what we need. And we probably need to show this, the banner that we had. New banner, this thing, and somewhere probably in amongst these many cards, we should add another card, or we can simply show X of Y credits used. Actually, credits just keep on decreasing, right? Total credits used is probably not something you want to show anyways. I'd probably just say credits available and then simply render user profile query dot is loading, then this thing else credits. Credits available, wait for it. The backend is down. Oh, sorry, I just need to restart the backend because I've changed something. And now hopefully I get back the credits here, which is 3000. That looks fine. And the usage here per API key, which is, something I don't care about right now. Cool. If I add 1000 credits, it should update. It doesn't update here because we probably need to on ramp mutation invalidate query of user profile as well, so it resends the request to get the new credits that the user has. So right now I have 4000 credits. I see them here. If I click on add credits, I see 5000 here as well as 5000 here. Beautiful. I see the API keys. I see the dashboard. That's pretty much it. You have credits. You can consume credits using the API keys. The thing that's left now, the tougher bit, not really tough now, honestly. I think the tougher bit is behind us, is going to be writing the API backend. where basically the user is going to hit one of our endpoints with an API key that they have generated. And we're supposed to route their request to one of many LLM providers and talk to the database from time to time to capture their credits usage and, token usage, so on and so forth. That's what we're going to do next. Next up, we're going to hit the API backend, create the API backend. Not yet probably do the time series DB or, stats wala part. We'll just focus on the API backend. So the user can hit our API backend. We can just route the request to the respective model that the user wants. Let's get into that section next, the final part, which is the actual API backend. All right, coming to the most interesting part, which is the primary backend and the API backend, probably the simplest part as well. Let's create probably again an Elysia app, even though we can create an Express app if we want. But I'll probably create an Elysia app. So rm-r API backend. And how do you initialize a new Elysia backend? Let's see. I'm sure there's a quick start, which we have seen in the past. This one right here, I'm going to call it API backend. CD API backend. The best part of this is that we only need one endpoint, which I can simply add here, which will be a post endpoint to conversations. What the schema looks like is going to be debatable. It can basically be, the input can be fairly complicated based on if you support images, tool calls, so on and so forth. For now, we'll keep things simple and we only support an array of messages, which if you've ever used OpenRouter or any other sort of API to an LLM. So let's just look at Claude API. Docs. What you send to the LLM is an array of messages. Quick start. There you go. Something like this messages, which is an array of messages, one from the user, one from the assistant, so on and so forth. So this is what our schema should look like as well, mota mota. Or what we can do is we can just follow what OpenRouter does. So OpenRouter docs. Yeah, our API should probably be compatible with OpenRouter. So let's see what they do. Meanwhile, let me just turn on my charger as well. I'm at 2%. All right, we're back. Let's look at the docs and let's see what the OpenRouter API looks like. Taking a long time. Finally here. It looks something like, wait for it, this. So it has a bunch of headers. We can ignore these two headers. These are both optional and probably used for some stats. The authorization header and the content type headers are the two important things that we need. So just like we can specify the body schema, t dot object of model, which is going to be a string or maybe an enum, but let's just do string for now. And then the second thing is going to be messages, which is going to be a t dot array of t dot object of role, which is probably a t dot enum of either user or assistant, and then content, which is t dot string. Something's up here. How do you define enums? Enum, user, and then assistant, t dot content, t dot string. I think that's all that a simple message holds, even though I think that there are a few things that we can add here. For example, streaming true or false, which should be a Boolean. We'll get there when we get there. The other thing is headers. Can we add header schema here? Headers. We probably can. It should have an authorization header. T dot string. Can you do that? Object string and then content type t dot literal application slash JSON. That's the only one we support in the input. That should be fine. Headers authorization, and body are the two inputs we get here. Let me just log them for now and ensure it does work. Headers, authorization, and then body, and return hi. Let's see, does that return what we expected to return? Bun index.ts, requestly, let's send the request to localhost colon 3000, even though this should be, something else, probably 4000. Slash conver, is that the endpoint here? Slash API slash v1 slash chat slash completions. So that's the one that we need to have as well. With the post request with a authorization header, bearer space some token, and then body that should have messages, which can be an empty array for now, and then model, which can be a random string for now. If I send this, it tells me expected string property authorization but found undefined. I think I'm sending an authorization header. Oh, I forgot one thing here, which is content type. What do we content? Is it content type or is it content dash type? It is content dash type. Actually, don't need that. Send. Yeah, let's just log authorization header directly here. If something's wrong, we'll just catch it here, give the user a better error. Let's do it one more time, and this time, now that's a problem. Oh, my bad. JSON send. There we go. All right. And did it log? It logged an empty authorization header, even though authorization, that looks fine to me. Let's try to log the headers, send, and we do have authorization, and as expected, it's just small a and not capital A. Send, and that should do it. I think there's an easier way to extract bearers in Elysia, or we can just write our custom logic. But generally, bearer auth is like fairly common. So we can actually just do this. Bun add Elysia slash bearer, followed by app dot use bearer, and that should simply give us access to the exact bearer header here. Let's run it again, and this time what should log is this string over here. Let's confirm if that's true. That is indeed true. Things become easy from here. The user has sent us a request to chat to a specific LLM. The first thing we need to do is ensure or check if the user's API key is valid. If it is valid, we need to send the request to the LLM. We need to get the response and go from there. So the next thing probably should be writing the LLM, specific calls. So I can create a new folder called LLMs. I can create a base.ts here, inside which I'm going to define, the base logic of a class. So export class base LLM, which has a static function called chat, maybe, which takes messages as an input, which is a message array. Let me just define. Oh, we can just infer that from here. Let's just create another file called types.ts, inside which I define this body, which I'm going to call conversation type, export const conversation equal to this thing, where t comes from the specific library, and ideally message type support const message type equal to this thing defined above here. Message type, conversation type, actually this should just be probably message and conversation, and the actual type can be export type message equal to type of message.static, which is what we will import here. This is what I need to forward to specific LLMs, and we should probably specify the response here as well, LLM response. This is again, I think, different for every LLM, but let's see what OpenRouter returns us. It would return us, is there a type here? Yeah, completion.choices of 0.message.content. It's like a fairly complicated object. Type LLM response equal to completions, which is an array of choices, which has a message, which has content, which is a string. It'll probably be a little more complicated than this, but for now, let's just do this and throw new error not implemented chat function. So what this is like a base class that other people need to extend and override this function, which is why if you don't override them, this will just throw an error. What I need to do now is create like a Google .ts or more technically probably gemini.ts and claude.ts and then openai.ts, where we're going to implement these individual elements or in these individual LLM calls. So export class Claude extends base LLM, where I'm going to overwrite the chat function to return the things that we expect to be returned from Gemini, which basically means we need to now either import the Gemini or in this case Claude, SDK. In this case, the Gemini SDK. Oh, rename. And in this case, the OpenAI SDK, and convert whatever format it returns things us in over to this LLM response that we have. Let's start off with Gemini. I think it's not too difficult, even though like it gets. I don't love looking at Google Docs because they're very enterprisey. Well, not as difficult as I was hoping for. They do have a JavaScript SDK that I probably can use. I probably should use. I'm probably going to use. So that's at Google/Gen AI. Let me do a bun add Google/Gen AI. This is me writing the logic to talk to Google if the user wants to talk to a Google model. Let me import and initialize. And then I probably need to pass an API key here, which I'm going to store in my .env file in the API backend. Google API key. And for those of you who don't know, I already have these API keys created and some credits put in Google OpenAI API key and then Claude API key. You can get your respective API keys by going to, for Google, going to Google AI Studio, clicking on Google AI Studio, Google AI Studio.google.com/app/API keys and creating a new API key. In my case, I have already done this and I've put some credits in all three of these. And I'm just going to copy paste them here without showing it to you guys on video. Let me do that next. Let me quickly copy paste the three, API keys that I have and not expose them on the internet. All right, that's done. I have the Google API key stored in my .env file. The next step is probably as simple as this is not the right one, but I think I can get there easily. Const response equal to AI.models.generate content. What does it take as an input? Model contents and what is content? Role and parts. List the parts that contain a single message. Each part may have different MIME types. Boy, that's not easy, is it? In our case, the MIME type is just, we just have text. So it will probably be contents is going to be messages dot map message text message dot content. It should be a string. Row. Why is there a two-sided array here? Oh, should probably be called messages, but it's fine, I guess. The hell? Oh yeah, this type should probably be called messages. Let me just change that. This is also messages. This is also messages. This is also messages. And if you go back to index.ts, this should just be conversation, and that's it. Messages. Go back here. Message.map message. How does it have an? There we go. Dot content, and then the second thing is role, which is going to be message dot role, and that's it. We get back a response whose type is generate content response. What we return from here is something in this format, completions, which is has messages or message. I don't know if that was true. OpenRouter completion or choices of 0. OpenRouter completion dot choices dot message dot content. Choices, which is an array of this thing. Dot message dot content. That looks fine to me. And this will be completions dot choices is going to be an array of message content response dot text. This isn't exactly correct. Ideally, this might return me multiple responses which I should send to the user, but I'm not doing that just yet. Completions, choices. Oh, completions wasn't an array, was it? No, it wasn't. So let me just get rid of this. Response.text. String or undefined is not assignable to text. I'm assuming, most probably incorrectly, that the text that we're getting back from the LLM is not null, but it might be. This should be promise of LLM response, and the same thing should apply here. Promise of LLM response. That's it. That should probably do it. Let's try it out. Oh, I'm missing one thing. Model should also be an input. So base LLM may model should also be an input, and the same should be true here. This is where things get a little tricky. The type should probably be better, and not a string here. but we'll roll with it for now. Okay, that looks good to me. Let's try out Gemini. If it works, OpenAI and Claude should be easy enough to add. Chat are incompatible. How? Model string. Oh, model and then messages. Model and then messages. Beautiful. Go back to index.ts in the API backend. And here, probably do a, I mean, we need to do a bunch of things, but for now, const model equal to body dot model. And then after the slash, we'll probably have whatever, the actual model name, const provider model name equal to dot split slash of 1. And then we can for now simply do Google or Gemini dot chat with the model comma or whatever provided model comma messages will simply be body dot messages, I think. Const response equal to this thing, and we can simply return the response here. Let's see if that is good or not. Of course, I'm not doing authentication right now. I'm forcing it to use Google right now, but it should be very easy to fix that. If I go back to, if I restart this API backend, and if I go back to requestly, let's see what this guy returns. It returns a 500 internal error with no clear contents are required. Body, model, oh, message, let's see, what was the type? Messages, type of message, which is role and then content. So role, user, content, what is 2 plus 2? I hope it returns me back a 4. Seems weird. Missing something obvious, most probably. Is the control ever reaching here? Console.log. Oh, model is not this. It's going to be Google slash, let's see, Gemini 3 flash preview for now. Send, and this time it's taking a long time, which is good, and it is returning me content from the LLM. Completions of choices of 0.message.content is 2 plus 2 is 4. Beautiful. What if I ask it something like, what is AI? I hope it returns me the right thing, which in this case is a very long essay, it seems, around what AI is. Beautiful. There are a few other things that we need from each one of these chat messages. It shouldn't be as simple as this. The LLM response should also tell me the input token and the output token usage. Input tokens consumed, which is a number. Output tokens consumed, which is a number. And what I need to do now is figure out in this response dot usage metadata dot total token count. Total number of tokens attack. This is a sum of prompt token count and oh, that's a lot. How do I get the input or output only? Candidates token details. Candidate total count. Total number of tokens in the generated candidates. So that's going to be 1, which is output tokens consumed. And then input token consumed is probably going to be output only tokens generated candidates, output only total tokens in the prompt. There you go, prompt token count. And based on these things, we have to do a few things, right? We have to decrease the user's credits, so on and so forth. Again, big assumption here that it'll always return something like this. Could be wrong. But for now, let's just see, do we actually, get back the token counts, the input and the output tokens consumed, which we eventually need to decrease the user's credits, because we're being charged on Google. We need to charge the end user, some extra amount on top of that. Input token, output token consumes this, input token consumes this. That looks good. What is AI question mark is probably 5 tokens, but the response is 845 tokens. Beautiful. Now things should be fairly simple. I can go back to the API backend and we can do a bunch of things. Const company name equal to model dot split of slash of 0, or we can simply do this company name comma this thing, and then if company name is Google, then we do this, simply actually return, I guess that's not true, this if company name equal to OpenAI, then pretty much the same thing but with OpenAI. And then lastly, if company name is Claude, actually should be Anthropic. I don't know actually. What does OpenRouter have? Does it have Claude or Anthropic? OpenRouter, let's go to the models. Let's see what happens when I search for Anthropic. The company name, it's Anthropic slash something, so it probably needs to be Anthropic. And here I'm going to do Claude.chat. That looks good to me. Let's start with implementing the OpenAI chat. Again, it should be fairly simple. Copy the function signature, paste it here. What we need to do now is go through the OpenAI docs. JS SDK. I'm sure they have a TypeScript SDK somewhere. Yeah, there you go. That looks simple enough. One, add OpenAI. API key process.env dot OpenAI API key. I think. Let me just move you guys off screen and confirm. That was indeed correct. It is OpenAI API key. The next thing is as simple as this: const response equal to await client.responses.create the model, which is whatever the user forwarded us, and the input, which again I hope can be a little more complicated, array of something. So messages.map message, I think it can be as simple as role, message.role, and then contents, message.content, return input token counts could be response dot max output tokens, usage dot, there you go, input tokens, and then output token count is going to be dot usage dot output tokens. Let's assume they do exist. And lastly, it needs to be again the fairly complicated object that we created in Gemini, which looks something like this. Response dot, let's see, output text. Right, that should hopefully do it. I think that should be good enough. If I go back to index.ts and if I check, if I now let's say company name OpenAI, and then model name. I can just simply do this. Restart the server, and then go to requestly. Change the model name to OpenAI slash GPT-3. I think that should do it. I would probably ask it, who are you and who made you? So we can confirm the request is actually going to OpenAI. And it says preview is not available. But I did get a 200. That happened quicker than I was hoping for. Company name is OpenAI. Control should reach here. But it seems like it isn't. It probably tells me company name is not OpenAI. Provider model name. Restart send, and I see G and then P. The hell? Model dots. Oh, my bad. Model dot split slash and not one. All right, there we go. It's taking some time, and then it returns me GPT 3.5. I think maybe, I don't know. What is the model called? GPT 5.2. Let's do that. Oh, it is. Oh boy, is it GPT slash or GPT dash 5.2? That's exactly what I did. Wait for it. Seems to work. I am ChatGPT, an AI language model. This is GPT 5.2. Beautiful. If I replace it with Google slash, whatever, Gemini 3 flash preview, I hope it returns me the same response from Google. I'm Gemini large language model. And lastly, the third one we need to implement is Claude or Anthropic, which should be simple enough again. We can simply search for Claude JS SDK. The SDK, the SDKs are actually cleaner than I was hoping for. All right, and Anthropic slash SDK. This would be a little different, something like this. And I think this is correct, but again, let me move you off the screen and confirm. It wasn't correct. I fixed it. Process.env.anthropic API key should be fine. And now simply need to do what these guys do here, which again, seems simple enough. Const messages equal to client.message.create. We probably should take max tokens as input from the user and then forward it here. But let's not do that just yet. Messages should simply be messages.map message. Role message.role and then content message.content. Looks easy enough. Model is going to be whatever model the user sent us. Return, again, a fairly complicated object like we have here. This is going to be response dot, let's see, usage dot input tokens, or sorry, output tokens. This is going to be response dot usage dot input tokens, and this is going to be response dot content. I think, yeah, let's do it, or maybe not. Oh boy. That's not great. So it'll basically be something like this. Dot content dot map content. Because we have multiple choices now, message content dot a content block can be many things, unfortunately. assuming it's a text block, it will simply be dot text. It could be something else. So if you want to support thinking, deep research, things like these, this code needs to change. Assume we don't support any of those yet. No images, no deep research, no thinking. And then what we've written over here sort of works. Basically works for simpler messages. Will not work for more complex messages. Something we should support eventually. All right, that is done as well. I think the rest was already implemented in API backend. The only thing that's left now is, we throw new error, model not found. The only thing that's left now is actually decreasing the user's credits, making sure they have enough credits, so on and so forth. Let's confirm though. Claude Opus 4.6. So let me go back to requestly. And let me change this with anthropic / Claude Opus 4.6. Now we get a 400. Your credit balance is too low to hit the API, Anthropic API. Could have sworn I had some money in there, but could also be wrong. Claude API credits. How much do I have in there? Let's see. Usage limits cost credits. Billing. Could have sworn I had $5 in there. Seems like I spent it on Claude Code. Pretty sure I won't be able to top up immediately. I'll just have to assume it will eventually work. Might not be able to test it today because this card is like a little weird. Or maybe I'm lucky tonight. Am I? Not here at least. Let's assume this will work eventually. I don't have enough, credits in my Anthropic to confirm it. But the other two are working. That's Google, seems to work. And that's OpenAI, that seems to work as well. The last thing that's left is, fairly simple again, something that I would generally wipe code. Just credit system, making sure the user has enough credits and actually decreasing their credits whenever a request goes through. So something like, also checking their API key. Const API key equal to db. Oh boy, we probably need to add db as a dependency here. Then we can do import Prisma from db. I could have sworn I can do that if I go back and do a global bar install apps / API backend. Seems to have not work. Import Prisma from db, exactly what I added here. If I go back to package.json, I added db in the wrong place. Haha, such an idiot. Let me redo that. cd bar install cd apps / API backend one dev or whatever. One dev indeed, or wait, hold on. Bunch of things are incorrect here. That's fine. And then API key equal to bearer or as API key. And given we have the user API key, the first thing we do is prisma.api key.find first, where API key is this API key, const API key equal to await this thing. And then if not API key db, we need to return status 400 and an error 403, an error that says message invalid API key. It should also not be disabled and not be deleted. Great. But if everything is good, the API key is correct, you'll go Oh, the next thing you need to check is if the user has enough credits or not. So when I'm getting this, I'll probably also get the user's ID. Uh, include ID true. Actually, user ID should already be there, right? In the API key, yeah. So I don't need to do that. I can include though credits. How much credits? Uh, if not user dot or API key db dot user dot credits is less than equal to 0, then we will stop this request right here with the payment failed status code, which I don't remember, but it should be payment failed, I guess. Payment isn't failing. 403 is fine. You don't have enough credits in your DB. But if everything is good other than that, then after everything happens, what we need to do is decrease the user's credits. So I would do something like API key DB dot, I guess we have to do two things. We have to decrease the credits for the user here. We have to increase the credits used or credits consumed for the user here. Thing is, yeah, we need to also figure out how do we calculate credits. If the user has spent X tokens, how much credits do we debit for them? We can have some sort of a multiplier. Const credits per token equal to, which again is sort of model specific. So actually the pricing should be somewhere here. Every model will have its own, every model provider mapping. Oh boy, we never really adhere to the providers, did we? Every model can have multiple providers. Yeah, we also need to check if this model is supported or not. There are a bunch of things that are left. The first thing we do is this. Then we check, does this model exist in our database or not? Model equal to await db dot or prisma dot model dot find first, where the slug for the model, ID, name, model slug. There you go. Slug is the same as the slug as the user provided us, which is going to be model. I would probably rename that, but that's fine. Model DB. If not model DB, we also tell the user, sorry, we don't support this model yet. This is an invalid model. We don't support. If that is not the case, then we need to find, or probably just here, include. Yeah, there are a few things we can do here, but what I'll do for now is const providers for this model equal to model db dot, sorry, prisma dot providers mapping dot find many, where model ID is this model, or model ID is model db dot ID. And once we have providers, what we can do is providers dot map provider. Yeah, here is where things get tricky. Ideally, based on this provider, we should do these things. So let me move this above. If not company name, so I can actually get rid of that now. If provider, or let me just select a random const provider equal to providers of math.random into providers.length math.float. And then once you have the provider, now when you do things like if provider is provider dot, oh, a lot of things here. Include model of provider true. If provider dot name is Google. Now, what did we store in the DB? Let me open another terminal. CD packages and DB. Bunex Prisma Studio. If the user wants their provider to be Google, or Google Studio, whatever, then we probably need to check this. It's weird. If the name is Google API, again, there's probably a better way to do this. I'm just adhering to schema for now. If it's Google API, then you do something. If it is Claude API, then you do this thing. If it is OpenAI, then you do this thing. And right now, I have not written the logic for Google Vertex. Might just make sense to get rid of it, to keep things simple. But if you, I mean, for now, even if it's Google Vertex, actually, that will not work. Google Vertex works with Claude as well. Yeah. Assume we don't support Google Vertex for now. So let me just get rid of this. I probably can't though, because there are a bunch of provider mappings where it is used. So I would, yeah, for now, I'm just going to do the same thing when the provider that gets selected is Google Vertex. This will not work because what I'm actually doing is not forwarding the request to Google Vertex but Gemini. And Gemini doesn't understand anthropic models. Google Vertex does. So I need to rewrite this. I need to create a new API key for Google Vertex, and only then it will work. Otherwise, the Gemini models the anthropic models will start to fail on Google Vertex, which again, we're selecting the provider randomly here, so it might happen from time to time that the provider that is selected is Google Vertex and not Google API. Here you can do a bunch of fancy things, figuring out which might be the best provider based on the current throughput from various clouds, or various API providers. So this is the most interesting part of the whole architecture, or performance optimization around where should the user's requests get forwarded based on the throughput that's coming from all of these providers. So I'd spend a lot of time here eventually, not right now though. Right now this should be good enough. Let's see if that's enough. What models do we support right now? We support OpenAI /GPT 2.5 Turbo. Let's see, does that actually work or not? Let me do a bun dev. Let me go back here. Let me select a model that actually is listed on our website, and see what does it say. I'm ChatGPT. That was quicker than I was hoping for, and that's because backend is probably not up. So bun dev, send that request, and now we get our first error. Invalid information here. My guesses in my .env, I don't have the database URL, so let me quickly add that. I don't want to show you guys my .env, and hence let me hide myself. Let me go to the primary backend, copy the database URL. Let me come back to the API backend.env, paste it, and let me restart the API backend. Hopefully it can now talk to the database. Seems like it can. It's still waiting, and the first model is not supported because it's an invalid API key. Beautiful. Let me add a real API key that was generated by my platform, which I can find here somewhere. API keys. Oh, I turned it off, didn't I? Or maybe not. Yeah, I turned it off. I can just start the front end and generate one from there. So cd cd apps / frontend bun dev. Seems like it's already running, and oh, I wouldn't think so though. Is it? Seems like it is. h2@gmail.com 123 random. The backend isn't though. See API backend one dev, sign in. Oh, primary backend. All right, wait for it. Signed in. I think I do have some credits in here. I on ramped a few a while back. I have 5,000 credits. Create a new API key. Let's call it prod, and then let me copy it, and then let me paste it in requestly as my header here. Now, hopefully, it should be able to send a request because I do have 5,000 credits. I should be allowed to send, a request using my API key. And indeed, it does work. What's the last thing that's left, folks? The last thing that is left is actually decreasing the user's balances based on, what happened here. So what I can do is let response LLM response or null equal to null. Return response. But before I return the response here, what I'm going to do is actually decrease the user's balance, the credit balance. So await Prisma dot transaction. Now, basically, I need to do two things. The first thing is Prisma dot user dot update one, where user ID update where ID is API key db dot user ID, and then set the data credits decrement by some number, basically a function of a lot of things. It should be a function of how expensive this model is into some multiplier. So for now, I'm going to hard code it, but ideally this decrement should happen based on if it's an expensive model, your more credit should go away, and this value will come from the database. If you remember, in the database we were actually storing how expensive a model is based on this model provider mapping, input token cost, output token cost. So ideally these should be taken into consideration. I'm not doing that yet, but you should add that logic here. For now, I'll just decrement whatever. Input token cost response dot input token consumed. Maybe I can actually do something from the database into model d provider dot input token cost. Plus response dot output tokens consumed into provider dot output token cost. And a function of this, again, we need to figure out what we store over here. It's ideally going to be cost per million tokens, something like that. So I don't love what I've written over here. I'm just going to also divide this by a very big number for now, because it'll probably be a very big number on paper. Yeah, I'll just get rid of all of my credits very quickly. But it should be a function of these two, right? It should be a function of the tokens consumed into the input cost price. But I need to put the right values in here and do some dollar conversions based on if a model costs $25 per million requests or per million input tokens. It needs to somehow be converted into our token representation, our credits representation. I have not done that yet. So we make randomly some function of input tokens consumed into input tokens cost use kar raha hu. Probably a better way to do it though. And whatever this thing is that you're decrementing, const credits used equal to this thing is the same thing. You need to sort of store here in the prisma.api key.update, where id is the API key db.id, where API key is this API key that the user sent, and set the data to have credits consumed increment by the same amount. Yeah, what does this do? It basically decreases my overall credits, but increases the credit consumed, value over here for that specific model or that specific provider. Let me, for that specific API key. Let me quickly update the model provider costs to some random number right now. So my model provider mapping, input token costs, whatever. This is, I'm putting in random values here. For the input token cost, and then random value for the output token cost as well. We should ideally change this to the real values representing. For a expensive model it should be more, for a cheaper model it should be less. All right, that should at least decrease some balance, which is what we want for now. All right, primary backend is up right now. On my OpenRouter dashboard, how much credits do I have? I have 5,000 credits. Let me try to consume some of these credits by using my API key and hitting the backend. Hitting the API layer to talk to an LLM, in this case OpenAI slash GPT 3.5 Turbo. I asked it, who are you and who made you? It returned me some response. Let me send it again, and hopefully it returns something similar again. But now that I've sent this request twice, I expect my credit account amount to go down, and I expect my API key usage to go up. Let's see, does that happen? That did not happen. Probably because it's a really small number that I'm decreasing, and just round down to 0. So I would probably change this multiplier to be something smaller. It's used. Let's see if that changes anything. Send a request. Did I restart the right thing? I don't think I did. I think I never restarted the API backend, which is why this happened. Let's try it one more time. This time when I send this request, it does return me what I want it to return me. The bigger thing is, if I refresh, wait for it, nothing happens. If I go back to the terminal, the credits that have been decreased are really less. They need to be more than 1, because what we're storing in the database is an integer. So if it's less than 1, it will basically not decrement anything. Now let's try it one more time. This time it should decrease like 10 credits from my account. If I refresh now, it shows me my credit balance is 5,000. Refresh again, 4984. 16 credits have been used over here. If I try to send the same request to Google slash, I don't know, Gemini 3 preview, is that the right model name? I don't know. We have to check, does our database support it or not? Our database, let's see, cd packages tb studio. Our database for the models, specifically Google models, let's see what does it support. It supports Google slash, wait for it, Gemini 2.5 Pro. So let me try that. I might have to add preview somewhere. That was incorrect, but let me send it again. This is a model we don't support. Google Gemini 2.5 Pro. This is one we should support, but I'm unsure if this is the exact title that reaches Google. I think there's a preview at the end. I could be wrong, actually. This seems like it's working. Invalid update. 84 const credits used equals unable to start transaction at this given time. I don't know what could have caused that. Let me try this one more time. If it doesn't fix it, just to decrease the complexity, I'm going to get rid of the transaction for now. The debits can actually happen asynchronously. The user shouldn't be waiting for the response while the credit is being consumed. So ideally what you really want to do is Probably want to put them inside a transaction. I'm not going to, and probably don't want to await them. If it gets missed, it gets missed. But the user should, probably see this response immediately. Ideally, what you want is, to process these debits asynchronously, and the user shouldn't be waiting for their balance to be debited before they can receive a response. Let's wait for it. And this time, hopefully, I get a response. Wait for it. Either Google is writing a lot of tokens, or this is just slow because of the database calls. Probably the second one seems to return something. And now, if I go back to my dashboard, I should probably see lesser credits. I still have 4984. Okay, let me just ask it something bigger. What is AI? Seems like the credits, either the credit count is too much. That's the only other thing I can think of. Console.log credits used. $4984 still, yeah, okay. Go back here. This is running. Let me send this question again to Google/Gemini 2.5 Pro. I expect it to return me a longer response, and hence I expect the amount of credits to be used to be a lot. Let's see what happens though. What response do I get back? Probably a long one because it's taking a long time. That's taking really long though. Return me a really long response around what AI is. The credits that I ended up using was 123, so I expect 123 credits to be decreased from here, which does not happen. Seems like credit decrements are failing, probably for a good reason. Yeah, I will have to just see what's up here. Const res equal to await this thing. Const res2 equal to await this thing. Console.log res and then res2. Seems like there's a simple bug somewhere. Go back here. Ask a simpler question. What is 2 plus 2? I'll save the requests, which is not the worst thing in the world. Send this request again. This time, wait for it. $3.1 credits, and seems like I was able to decrement correctly. I got the response. If I go back here and refresh, it'll still say 4984. No, it says 4981. What happened? Let me send it again. Seems to have, still sending the request. Looks good. Seems to have decreased. What happens when I ask it a bigger question? What is AI? Why does the math not math, and why does it go crazy? I've asked it a bigger question this time. This is going to take longer. But what we've seen is whenever this happens, the decrement request fails for some reason. So we'll see what's up there. That's taking really long. It's probably supposed to 350. And this time, again, it sort of seems to have worked, which is not great. I just spent 300 credits on a simple message, and the usage looks fine as well. Let me add another API key called, staging. Let me copy the API key. Let me send these requests from this staging API key just to ensure it's, incrementing the right things at the right place. What is 2 plus 2? And maybe again, OpenAI slash GPT-3. Let's send this request. It should return a fairly simple response. Probably should also not consume a lot of tokens. This is a, what is it? 3.5 or 3-5? What models do we support? Going back here, We support OpenAI slash GPT-5 Nano, so let's try that. Send. And this time, hopefully, I don't see that response. Seems like I don't. Do I see a different response? Not yet. I do. It does return me. Wow, a little too much. If you're asking a different base, I didn't ask that. It seems like it answered. It spent 124 credits. That's a lot of credits. It did decrease the credits. If I go back to my API dashboard, I can probably see I have 3 API keys now, and usage across the 3 API keys looks like this. For prod, I've spent this much, staging this much, type this much. Beautiful. That is what we expected. We've been able to finish OpenRouter end to end. You can come sign up over here. After you sign up, it'll show you how many API keys that you have that are active. How many credits have you used? What are the currently available models? We can add more tabs here to see the models, their details, more blocks around them, the providers that the model supports, more stats around them, so on and so forth. You can create API keys from here. I have 3 of them right now, and you can track your credits. Right now, we don't have Razorpay. Ideally, you shouldn't be able to click a button to increase your credits, which is what we do right now. Ideally, a Razorpay pop-up should pop up. User should put 100 rupees, and when they do, should they receive 10 credits, 20 credits, whatever that amount is. Once the user has done that, they can create an API key, copy it, go to their favorite testing platform, their Node.js app, their Rust app, Bun app, whatever, and hit our api.100xdevs.com/API/v1/chat/completions. Give us the message that they want the answer for, which could be something like what is the sum of 2 plus 2, or something more complicated like, I don't know, write simple Rust program. When they send this request, they're going to receive a response from the LLM. We will see this response here, and their credits will be debited based on the input tokens and the output tokens, and the input token cost for GPT-5 Nano, the output token cost for GPT Nano. It did return me a simple hello world program in Rust here. If I go back here to the credits, you will see they've gone down from 5504 to 5341. So I've just spent, whatever, 100 credits sending that one API request. Cool. Hopefully you understand what's done. What extra can you add in here? What are things I would love to see? The project is open source. We have been able to build this. What we have not yet built is, number one, would be nice to see some sort of a time series DB and tracking around, daily, how many credits are you spending, the throughput of these models, how well these models are performing. Let me just write these things down. First thing I'd love to see here is metrics around your usage and model throughput. Number two, streaming. One big thing we haven't yet supported is how can the user send stream through and stream the response from our backend rather than getting the whole response in one go. Very important thing you should probably add. Three would be the currency system isn't great right now. You can't, number one, you can't on ramp using Razorpay or Stripe right now, and number two, the way we're debiting credits is not great right now. There's like a weird function that I have written, which is this one right here, to figure out how much credit should be consumed for a specific request. This should change to something more complicated, something more apt. If I am whatever, spending $5 on OpenAI, me as in OpenRouter or the central layer, I should charge the end user, $5 plus some 5%. That's the credits that should be decreased for that specific user. That should be another thing I would like to add here. SDKs. I have not yet added, a JS SDK, a TS SDK, so on and so forth. They're easy to add now that we're using Elysia. Elysia lets you basically export an OpenAI, Open API, my bad, spec for this. If you add, I would assume one add Elysia/Open API. My assumption seems to be correct. No, incorrect. But just go through Elysia docs. You'll find an OpenAI integration. It comes from at ElysiaJS/OpenAI. Just adding this much will export an OpenAPI key, and using that, you can create any SDK you want for JavaScript, TypeScript, Golang, Rust, so on and so forth. And 5 would be a docs page where the user can actually go through these docs and understand how they can integrate with our website. A sixth thing I can think of, and again, there's no end to these, would be a Vercel AI SDK integration, which gets a little tricky. And I'm sure, it gets trickier for other SDKs as well. So here are a few thoughts on, if you did like the video, were able to code it yourself, what can you do from here? Because it's not really, a fully fledged application. I can deploy it, but, I just burn 2 credits without charging the end users anything. There are a few things to do before you call it a finished end-to-end project that you can productionize for end users. If you're doing for your portfolio, sure, this should probably cover it. But I would still, go over the edge and try to build some of these features that are missing right now. Before you can call this an end-to-end finished application. Hopefully, this was an insightful video for everyone. Hopefully, you learned something new. I think it wasn't too long. I think 3 to 4 hours. Let me know if there's any other specific project you guys would want me to build. And if you are looking for an API client, which is the one that we used today, and I recommend you guys use, it is Requestly. Thank you, Requestly, for sponsoring the video. With that, we'll end it. I'll see you guys in the next one. Bye-bye.